In 1990, a spacecraft named Voyager 1 turned its camera toward Earth from 4 billion miles away and captured something extraordinary, a tiny, pale blue dot suspended in a vast, dark expanse. This single image, now known as the pale blue dot, didn't just show us our planet, it showed us ourselves. For the first time, humanity saw Earth not as a collection of borders, nations, or continents, but as a fragile, interconnected speck in the cosmos. That moment changed everything. It forced us to confront a profound truth. We are all part of something much larger than ourselves. But what does it truly mean to see Earth from space? How does that perspective shape the way we think about our planet, our place in the universe, and our future? Space exploration doesn't just take us to the stars, it brings us back to Earth with a new understanding. It reveals the delicate balance of our atmosphere, the intricate systems that sustain life, and the urgent need to protect our shared home. From climate science to global unity, the cosmic perspective reshapes how we see everything. In this video, we'll explore the profound ways space exploration transforms our understanding of Earth. We'll dive into the science, the stories, and the moments that redefine what it means to live on this pale blue dot. So, let's embark on this journey together through the cosmos and back to Earth, to uncover how looking outward helps us see inward like never before. There's something almost magical about the way astronauts describe their first glimpse of Earth from space. It's not just a visual experience, it's a transformation, a moment that rewires how they see the world and their place in it. This phenomenon is known as the overview effect, a term coined by author Frank White in the late 1980s. It's the profound sense of awe and interconnectedness that astronauts feel when they see our planet from orbit, suspended in the darkness of space. Edgar Mitchell, one of the astronauts who walked on the moon, once described Earth as a living, breathing organism, a vibrant blue and white sphere teeming with life against the infinite black void. Chris Hadfield, who spent months aboard the International Space Station, echoed this sentiment, calling Earth a fragile oasis that demands our care and respect. These aren't just poetic descriptions, they're reflections of a fundamental shift in consciousness. From space, there are no borders, no nations, no divisions. What astronauts see is a single, interconnected ecosystem, a shared home for all of humanity. This perspective doesn't just change how astronauts think, it challenges how we all think. The overview effect forces us to confront the artificiality of the lines we've drawn on maps. It highlights the absurdity of conflict over resources or territory when, from above, the planet appears as one unified whole. It's a reminder that the air we breathe, the water we drink, and the soil we cultivate don't belong to any one country. They are part of a global system that sustains us all. But the overview effect isn't just about philosophy or emotion. It has real-world implications. This shift in perspective has inspired astronauts to advocate for environmental protection, global cooperation, and sustainable practices. It's influenced scientific research, pushing us to study Earth as a single, complex system rather than a collection of isolated parts, and it's shaped policy making, encouraging leaders to think beyond national interests and consider the well-being of the entire planet. Imagine, for a moment, what it would be like to see Earth from that vantage point. Picture the swirling white clouds, the deep blue oceans, and the thin, shimmering layer of atmosphere that protects us from the harshness of space. Now imagine feeling, in that moment, a deep sense of responsibility, not just for your own home or country, but for every living thing on this planet. That's the power of the overview effect, and as we continue to explore space, this perspective may hold the key to solving some of our greatest challenges here on Earth. The Earth isn't just a planet, it's a living, breathing system, a delicate dance of interconnected processes that sustain life in ways we're only beginning to fully understand. This idea isn't new. Back in the 1970s, scientist James Lovelock introduced the Gaia Hypothesis, proposing that Earth functions as a single, self-regulating organism. At the time, it was a radical concept, suggesting that everything from the atmosphere to the oceans works together in a finely tuned balance to maintain conditions suitable for life. Today, thanks to space exploration, we have more evidence than ever to support this idea, and it's reshaping how we see our planet. Satellites orbiting high above Earth have given us a bird's-eye view of the planet's systems in ways we could never achieve from the ground. They've revealed intricate climate patterns, the vast networks of ocean currents, and even the subtle ways forests and phytoplankton influence the atmosphere. These observations have shown us that Earth's systems are deeply interconnected, responding to changes in ways that often feel almost intentional. For example, when carbon dioxide levels rise, plants and oceans absorb more of it, acting as natural buffers. It's as if the planet has its own built-in mechanisms for maintaining balance, a concept at the heart of the Gaia hypothesis. One of the most striking examples of this self-regulation is the recovery of the ozone layer. In the 1980s, scientists discovered a massive hole in the ozone layer over Antarctica, caused by human-made chemicals like chlorofluorocarbons, or CFC. The discovery sparked global action, and thanks to international agreements like the Montreal Protocol, the use of these harmful chemicals was drastically reduced. Satellites have since tracked the ozone layer's gradual recovery, showing how Earth's systems can heal when given the chance. It's a powerful reminder that while we can disrupt the planet's balance, we can also work with it to foster recovery. Space-based technologies have become indispensable tools in monitoring and understanding these changes. Instruments like NASA Terra and Aqua satellites provide real-time data on everything from deforestation to polar ice melt, giving scientists the information they need to track environmental shifts and predict future trends. This data doesn't just help us understand Earth as a system, it empowers us to protect it. For instance, satellite observations have been critical in tracking the impacts of climate change, from rising sea levels to shifting weather patterns, offering a global perspective that ground-based measurements alone can't provide. This view of Earth as a single, interconnected system has profound implications for how we approach global challenges. It reminds us that actions in one part of the world can have ripple effects across the entire planet. A factory emitting greenhouse gases in one country can contribute to rising temperatures on the other side of the globe. A forest cleared for agriculture in one region can disrupt rainfall patterns thousands of miles away. Recognizing these connections forces us to think beyond local or national interests and consider the health of the planet as a whole. As we continue to explore space, this perspective becomes even more critical. The tools and insights gained from studying our own planet from above are helping us tackle some of the most pressing issues of our time, from climate change to biodiversity loss. And as we look to the stars, we're reminded that Earth is our only home, a fragile, interconnected system that depends on our care and stewardship. The more we understand it, the better equipped we are to protect it. This brings us to the next chapter of our journey, how space exploration isn't just about understanding Earth. It's about using that understanding to address the challenges we face here on the ground. From climate science to disaster response, the lessons we learn from above are shaping the future of life below. From the vantage point of space, the story of climate change unfolds in ways that ground-based observations simply can't capture. Satellites orbiting Earth have become our eyes in the sky, offering a comprehensive view of the planet's shifting climate systems. These tools have revolutionized our understanding of environmental changes, revealing patterns and trends that span continents and decades. They've shown us not just the scale of the problem, but also the interconnected nature of Earth's systems, how a warming atmosphere affects polar ice, how deforestation disrupts rainfall patterns, and how rising sea levels reshape coastlines thousands of miles away. One of the most powerful tools in this effort is NASA's Earth Observing System, a constellation of satellites designed to monitor the planet's health. These satellites provide real-time data on everything from carbon dioxide levels to the extent of polar ice caps. For example, instruments like the Moderate Resolution Imaging Spectroradiometer, or MODIS, track changes in land cover, helping scientists measure deforestation rates in the Amazon or the spread of wildfires in Australia. Meanwhile, the Gravity Recovery and Climate Experiment, known as GRACE, measures changes in Earth's gravitational field, revealing how much ice is being lost from glaciers and ice sheets in places like Greenland and Antarctica. The data these satellites collect is both staggering and sobering. Time-lapse images of shrinking glaciers and retreating ice shelves paint a vivid picture of a planet in flux. Over the past few decades, we've seen the Arctic lose more than half of its summer sea ice, while Antarctic ice shelves the size of small countries have collapsed into the ocean. These changes aren't just abstract numbers on a graph, they are visible, tangible shifts that underscore the urgency of the climate crisis. From space, the evidence is undeniable. Earth systems are under stress, and the clock is ticking. But satellites don't just show us the problem, they help us understand it. By tracking greenhouse gas emissions, they've revealed how human activities, from burning fossil fuels to industrial agriculture, are driving climate change. They've also highlighted natural processes that can either amplify or mitigate these effects. For instance, satellite data has shown how forests act as carbon sinks, absorbing vast amounts of CO2, but also how deforestation turns them into carbon sources, releasing stored carbon back into the atmosphere. This information is crucial for developing strategies to reduce emissions and protect vital ecosystems. The cosmic perspective also brings a sense of urgency to the fight against climate change. From space, the thin blue line of Earth's atmosphere looks impossibly fragile, a delicate shield that protects us from the harshness of space. Seeing it from this vantage point makes it clear there's no backup planet, no second chance. This perspective has inspired global efforts to address climate change, from the Paris Agreement to local initiatives aimed at reducing emissions and promoting sustainability. It's a reminder that while the challenge is immense, so is our capacity for innovation and cooperation. Data from space isn't just shaping global policies, it's empowering individuals to take action. Apps and platforms that use satellite data allow people to track air quality in their neighborhoods, monitor deforestation in real time, or even see how their local coastlines are changing. This democratization of information makes the climate crisis personal, connecting global trends to everyday experiences. It's one thing to hear about rising sea levels in a news report. It's another to see how they might affect your own community. As we continue to explore the cosmos, the lessons we learn about Earth become even more critical. The same technologies that help us study distant planets are also helping us understand our own. They're revealing not just the challenges we face, but also the solutions within our reach. From space, we see a planet in need of care, a reminder that our actions today will shape the future of this fragile, interconnected system we call home. When we look beyond Earth, we're confronted with a stark reality. Our planet is a rare gem in a vast and unforgiving cosmos. The solar system is filled with worlds that remind us just how exceptional Earth truly is. Take Mars, for example, a planet often romanticized as a potential second home for humanity. But the reality of Mars is far from welcoming. Its surface is a barren, frozen desert, pockmarked with craters and bombarded by radiation. Unlike Earth, Mars lacks a global magnetic field, leaving it vulnerable to the full force of the Sun's solar winds. Over billions of years, these winds have stripped away much of its atmosphere, turning what might have once been a warmer, wetter world into the cold, desolate landscape we see today. Mars teaches us a critical lesson. Without the protective shield of a magnetic field and a robust atmosphere, even a planet with the potential for life can become inhospitable. Then there's Venus, Earth's so-called twin, which tells a cautionary tale of what happens when a planet's climate spirals out of control. Venus is a world shrouded in thick clouds of sulfuric acid, with surface temperatures hot enough to melt lead, a result of a runaway greenhouse effect. While Earth's greenhouse gases help maintain a stable, livable temperature, Venus's atmosphere traps heat so effectively that it has turned the planet into a scorching inferno. Studying Venus has given scientists a clearer picture of how delicate Earth's climate balance really is. It's a reminder that even small changes in atmospheric composition can have catastrophic consequences, reinforcing the need to protect our own planet's fragile systems. Beyond our solar system, the study of exoplanets' worlds orbiting distant stars has further deepened our appreciation for Earth's uniqueness. Astronomers have discovered thousands of these planets, ranging from rocky super-Earths to gas giants, but few, if any, appear to have the precise conditions needed to support life as we know it. Many are either too close to their stars, baking under intense heat, or too far away, locked in perpetual ice. Others lack the right mix of elements or the stability required for life to thrive. These discoveries highlight just how rare and precious Earth's habitability is. It's as if our planet is a lifeboat adrift in the vast ocean of space, offering a safe haven in an otherwise hostile universe. These lessons from other worlds aren't just scientific curiosities, they're urgent reminders of the need to protect Earth's delicate balance. The absence of a magnetic field on Mars shows us how vital Earth's magnetic shield is in protecting us from harmful radiation. The runaway greenhouse effect on Venus underscores the dangers of unchecked climate change, and the rarity of habitable exoplanets drives home the point that there's no backup planet waiting for us. Earth is our one and only home. This understanding has profound implications for how we approach sustainability and conservation. Space exploration doesn't just inspire us to look outward, it compels us to look inward and rethink how we treat our planet. Technologies developed for space missions, from solar panels to water recycling systems, are now being adapted to address environmental challenges here on Earth. The same precision instruments used to study distant planets are helping us monitor deforestation, track pollution, and predict the impacts of climate change. In a sense, space exploration has become a powerful tool for protecting the very planet that made it possible. As we continue to explore the cosmos, we're reminded that Earth's fragility is also its strength. Its delicate balance of atmosphere, water, and temperature is what makes life possible, but it's also what makes it vulnerable. By studying other planets, we gain not just a deeper understanding of the universe, but a clearer vision of what's at stake here on Earth. And perhaps in this cosmic perspective, we'll find the inspiration and wisdom to safeguard our home for generations to come. Space exploration has always been about pushing boundaries, not just in the cosmos, but also in the realm of innovation. Many of the technologies developed for missions beyond Earth have found surprising and transformative applications right here on the ground. These advancements aren't just about reaching distant stars. They're about solving some of the most pressing challenges we face on our own planet. From renewable energy to efficient resource management, the tools born from space exploration are helping to build a more sustainable future. Take solar panels, for example. Originally designed to power spacecraft in the harsh environment of space, solar technology has become a cornerstone of the global push toward renewable energy. The need for lightweight, durable, and highly efficient energy sources in space led to breakthroughs that have revolutionized how we harness the sun's power on Earth. Today, solar panels are a common sight on rooftops and in solar farms, providing clean energy to millions of homes and businesses. This technology, born from the demands of space travel, is now a key player in reducing our reliance on fossil fuels and combating climate change. Water is another critical resource that space exploration has helped us manage more sustainably. In the confined environment of a spacecraft, every drop of water is precious. To address this, NASA developed advanced water purification systems capable of recycling wastewater into clean, drinkable water. These systems, initially designed to support long-duration missions, have been adapted for use in remote and water-scarce regions on Earth. For communities struggling with access to clean water, this technology offers a lifeline, turning what was once undrinkable into a vital resource. It's a powerful example of how space innovation can address real-world challenges, improving lives while promoting sustainability. Precision agriculture is yet another area where space technology is making a significant impact. Satellites orbiting Earth provide farmers with detailed data on soil health, moisture levels, and crop conditions, allowing them to optimize their practices with unprecedented precision. NASA collaboration with agricultural experts has led to the development of tools like the Landsat program, which uses satellite imagery to monitor crop growth and detect potential issues before they become problems. This data-driven approach not only boosts crop yields, but also reduces the need for water, fertilizers, and pesticides, making farming more efficient and environmentally friendly. One standout example is the partnership between NASA and farmers in California's Central Valley, a region known for its vast agricultural output. By using satellite data to monitor soil moisture and irrigation needs, farmers have been able to reduce water usage by up to 25% while maintaining or even increasing their yields. In a world where water scarcity is a growing concern, innovations like these are proving invaluable. They show how space technology can be harnessed to address some of the most urgent challenges of our time, from food security to sustainable resource management. These technologies are more than just tools, they're testaments to the power of ingenuity and collaboration. The same spirit of international cooperation that drives space exploration is also essential for tackling global environmental challenges. Just as nations come together to build and operate the International Space Station, they must work collectively to protect Earth's ecosystems and ensure a sustainable future for all. The parallels are striking. Both endeavors require shared goals, pooled resources and a commitment to overcoming obstacles for the greater good. As we look to the stars, we're reminded that the solutions to many of Earth's challenges may already be within our reach. The technologies developed for space exploration are not just helping us understand the universe, they're helping us care for our planet. And in this shared effort, we find a powerful reminder that our future, both here on Earth and beyond, depends on our ability to innovate, collaborate, and act with purpose. The International Space Station stands as one of humanity's most extraordinary achievements, not just for its scientific breakthroughs, but for what it represents, a symbol of what we can accomplish when nations come together. Floating 250 miles above Earth, the ISS is more than a laboratory. It's a testament to the power of international collaboration. Built and operated by space agencies from the United States, Russia, Europe, Japan, and Canada, the station has hosted astronauts from over 20 countries, each contributing their expertise and resources to a shared goal. It's a microcosm of global unity, proving that even in an era of political tensions, cooperation is not only possible but transformative. This spirit of collaboration didn't happen by accident. The ISS required unprecedented levels of trust and coordination, from the design of its modules to the daily operations that keep it running. Astronauts from different nations live and work side by side, relying on one another for survival in the unforgiving environment of space. They share meals, conduct experiments, and solve problems together, embodying a vision of humanity that transcends borders. This isn't just teamwork, it's a model for how we can tackle other global challenges, from climate change to resource scarcity, by pooling our knowledge and resources for the common good. The success of the ISS has inspired other collaborative efforts in space exploration. Take the European Space Agency's partnership with NASA, for example. Together, they've launched missions like the Hubble Space Telescope and the James Webb Space Telescope, which have revolutionized our understanding of the universe. These projects require years of planning, shared funding, and the combined talents of scientists and engineers from multiple countries. The result, discoveries that no single nation could have achieved alone, from the first images of distant galaxies to the detection of water on Mars. But the benefits of international cooperation extend far beyond individual missions. Organizations like the United Nations Office for Outer Space Affairs play a crucial role in ensuring that space remains a peaceful and shared resource. By promoting treaties and guidelines, they help prevent conflicts and encourage the responsible use of space technology. This framework of cooperation is essential as more nations and private companies venture into space, ensuring that exploration remains a force for good rather than competition. What makes these partnerships so powerful is their ability to unite people around a common purpose. In space, national boundaries fade away, replaced by a shared sense of curiosity and responsibility. This mindset is exactly what we need to address pressing global issues here on Earth. Climate change, for instance, doesn't recognize borders. It's a challenge that affects us all. The same collaborative spirit that powers the ISS could drive international efforts to reduce emissions, protect ecosystems, and transition to renewable energy. After all, if we can build a space station together, why not a sustainable future? Scientific research is another area where international collaboration shines. Data collected from satellites and space missions is often shared openly, allowing researchers around the world to study everything from weather patterns to ocean currents. This open exchange of information accelerates discoveries and ensures that the benefits of space exploration are felt globally. For example, satellite data on deforestation in the Amazon is used not just by Brazilian scientists, but by researchers in Europe, Asia, and beyond. This shared knowledge fosters a deeper understanding of Earth's systems and empowers nations to make informed decisions about conservation and development. The lessons we've learned from space collaboration are clear. When we work together, we achieve more. The ISS and other joint missions show us that unity is not just an ideal, it's a practical strategy for solving complex problems. As we face the challenges of the 21st century, from environmental crises to technological disruptions, this model of cooperation offers a roadmap for progress. It reminds us that while our differences may define us, it's our shared aspirations that will propel us forward. Looking ahead, the potential for international collaboration in space and on Earth is limitless. As we prepare for missions to the Moon, Mars, and beyond, the partnerships we build today will shape the future of exploration and innovation. And perhaps in the process, they'll also help us rediscover what it means to be part of one global community, united by our curiosity, our resilience, and our determination to reach for the stars. When disaster strikes, time is everything. Whether it's a hurricane barreling toward a coastal city or a wildfire spreading across a dry landscape, the ability to predict, track, and respond to these events can mean the difference between life and death. This is where satellites become indispensable. Orbiting high above Earth, these technological marvels provide a bird's-eye view of our planet, offering real-time data that helps us anticipate and manage disasters with unprecedented precision. From tracking the formation of hurricanes to mapping flood zones, and even detecting the subtle shifts that precede earthquakes, satellites have become one of humanity's most powerful tools for disaster management. Take hurricanes, for example. Satellites like NOAA series are equipped with advanced sensors that monitor atmospheric conditions, tracking everything from wind speeds to cloud formations. These instruments allow meteorologists to predict the path and intensity of a storm days before it makes landfall, giving communities critical time to prepare and evacuate. During Hurricane Harvey in 2017, satellite data played a pivotal role in issuing timely warnings, helping to save countless lives even as the storm unleashed unprecedented rainfall and flooding across Texas. But satellites don't just predict disasters, they also help us respond to them. When wildfires rage through forests and neighborhoods, satellites like NASA Terra and Aqua provide infrared imagery that detects heat signatures, even through thick smoke. This information guides firefighters on the ground, helping them pinpoint the fire's location and predict its spread. Similarly, during floods, satellites like the European Space Agency's Sentinel-1 use radar to map inundated areas, identifying which roads are impassable and which communities are most at risk. These maps are invaluable for coordinating rescue efforts and delivering aid to those in need. One of the most striking examples of satellite technology in action is the early warning system for tsunamis. After the devastating Indian Ocean tsunami in 2004, which claimed over 230,000 lives, the international community recognized the urgent need for better monitoring. Today, a network of satellites and ocean buoys works together to detect underwater earthquakes and measure changes in sea level. When a potential tsunami is detected, alerts are sent to coastal communities within minutes, giving people time to move to higher ground. This system has already proven its worth, saving lives during events like the 2011 Tohoku earthquake and tsunami in Japan. The economic impact of these technologies cannot be overstated. By providing early warnings and accurate data, satellites help reduce the financial toll of disasters, For instance, flood mapping during extreme weather events allows governments and insurance companies to assess damage more quickly, speeding up recovery efforts and minimizing economic losses. In the aftermath of Hurricane Katrina in 2005, satellite imagery was used to assess the extent of the flooding, guiding the allocation of resources and reconstruction efforts. The ability to respond swiftly and effectively not only saves lives, but also helps communities rebuild faster and more efficiently. What makes satellite technology even more remarkable is its ability to adapt and improve over time. As new satellites are launched and existing ones are upgraded, their capabilities continue to expand. For example, the latest generation of weather satellites can now capture images in higher resolution and with greater frequency, providing more detailed and timely information. This ongoing evolution ensures that our ability to predict and respond to disasters keeps pace with the growing complexity of the challenges we face. Looking ahead, the role of satellites in disaster management is only set to grow. As climate change intensifies extreme weather events, the need for accurate, real-time data will become even more critical. Satellites will play a key role in monitoring rising sea levels, tracking the spread of droughts, and predicting the likelihood of wildfires. And as we continue to explore space, the technologies we develop for missions to distant planets will further enhance our ability to safeguard life here on Earth. In a world where disasters can strike without warning, satellites offer a lifeline, a way to see the unseen, to prepare for the unpredictable, and to respond with confidence. They remind us that even in the face of nature's most powerful forces, we have the tools and the ingenuity to protect ourselves and each other. And as we look to the stars, we're reminded that the same technology that helps us explore the cosmos also helps us care for our home. Space exploration isn't just about reaching distant planets or peering into the cosmos. It's also about protecting the incredible diversity of life right here on Earth. Satellites orbiting our planet have become powerful allies in the fight to conserve biodiversity, offering tools and insights that were unimaginable just a few decades ago. From tracking the movements of endangered species to monitoring the health of entire ecosystems, space-based technologies are transforming how we understand and protect the natural world. One of the most remarkable applications of satellite technology is in tracking animal migrations. Take the journey of the Arctic tern, for example, a bird that travels from pole to pole, covering tens of thousands of miles each year. Using GPS tags and satellite data, scientists can now map these epic migrations in real time, uncovering critical stopover points and habitats that need protection. This information isn't just fascinating, it's vital for conservation efforts, helping to identify areas where human activity, like shipping routes or urban development, might threaten these long-distance travelers. By understanding where and when animals move, we can create policies that safeguard their paths and ensure their survival. Deforestation, one of the greatest threats to biodiversity, is another area where satellites are making a difference. Instruments like NASA Landsat and the European Space Agency's Sentinel satellites provide detailed images of Earth's forests, allowing researchers to monitor changes in tree cover with astonishing precision. In the Amazon rainforest, for instance, satellite data has revealed alarming rates of deforestation, prompting governments and conservation groups to take action. Projects like Global Forest Watch use this data to create interactive maps that show deforestation in near real time, empowering activists, policymakers, and local communities to hold illegal loggers accountable and protect vulnerable habitats. Endangered species also benefit from the watchful eyes of satellites. In Africa, conservationists are using satellite imagery to monitor elephant populations and combat poaching. By analyzing changes in vegetation and water sources, researchers can predict where elephants are likely to gather, allowing rangers to focus their patrols in high-risk areas. Similarly, in the oceans, satellites help track the movements of marine species like whales and sea turtles, providing data that informs the creation of marine protected areas. These efforts not only help protect individual species, but also preserve the delicate balance of entire ecosystems. One standout initiative is the Global Biodiversity Information Facility, or GBIF, which uses data from satellites and other sources to map ecosystems around the world. By compiling information on species distributions, habitats, and environmental conditions, the GBIF provides a comprehensive picture of global biodiversity. This data is invaluable for conservation planning, helping scientists identify areas of high ecological value and prioritize efforts to protect them. For example, satellite maps have been used to identify coral reefs that are particularly resilient to climate change, guiding conservation strategies to safeguard these underwater treasures for future generations. The impact of these technologies extends far beyond individual projects. By providing a global perspective, satellites help us see the connections between ecosystems and the ways human activities affect them. A forest cleared in one part of the world can disrupt rainfall patterns thousands of miles away. A coral reef damaged by pollution can impact fisheries that feed millions of people. This interconnected view reinforces the importance of conservation, reminding us that protecting biodiversity isn't just about saving individual species, it's about preserving the intricate web of life that sustains us all. But perhaps the most profound impact of space exploration on biodiversity conservation is the way it inspires us to see Earth in a new light. From space, our planet's beauty and fragility are undeniable. The swirling blues of the oceans, the vibrant greens of the forests, and the stark contrasts of deserts and glaciers remind us of the incredible diversity of life that calls this planet home. This perspective fosters a deeper connection to nature, a sense of stewardship that transcends borders and cultures. It's a reminder that we are all custodians of this shared home, responsible for protecting its wonders for generations to come. As we continue to explore the cosmos, the lessons we learn from space are helping us become better guardians of Earth. The same tools that allow us to study distant stars are also helping us map the habitats of endangered species, monitor the health of ecosystems, and predict the impacts of climate change. In this way, space exploration isn't just about reaching outward, it's about looking inward, understanding our place in the universe, and taking action to preserve the incredible diversity of life that makes Earth so unique. For centuries, humanity has gazed at the stars and wondered, are we alone? This question isn't just a philosophical musing, it's a driving force behind some of the most ambitious missions in space exploration. The search for extraterrestrial life is more than a quest for discovery. It's a journey that challenges our understanding of life itself and our place in the cosmos. From the dusty plains of Mars to the icy oceans of Europa, scientists are scouring the solar system for signs of microbial life, and what they find could fundamentally reshape how we see Earth. Take Mars, for example. This barren, rust-colored world has long fascinated us as a potential haven for life. Over the years, missions like Curiosity, and Perseverance rovers have scoured its surface, analyzing rocks and soil for clues. What they've found so far is tantalizing evidence of ancient rivers, lakes, and even organic molecules, the building blocks of life. While we haven't discovered definitive proof of past or present life on Mars, these findings suggest that the planet was once far more Earth-like than it appears today. If life did exist there, even in the simplest forms, it would force us to rethink our assumptions about Earth's uniqueness. Suddenly, life wouldn't be a rare anomaly, it would be a cosmic possibility. But Mars isn't the only place where scientists are searching. Jupiter's moon Europa, with its icy crust and hidden ocean, has emerged as one of the most promising candidates for extraterrestrial life. NASA's upcoming Europa Clipper mission aims to study this enigmatic moon up close, using advanced instruments to probe its subsurface ocean. The idea of liquid water beneath the ice, combined with the potential for hydrothermal vents on the ocean floor, has astrobiologists buzzing with excitement. If life exists in such extreme conditions, it would expand our definition of what's possible, showing that life isn't confined to the warm, sunlit environments we're familiar with on Earth. Astrobiologists often talk about the habitable zone, the region around a star where conditions might be right for liquid water and, potentially, life as we know it. But missions like these are challenging that concept. They're revealing that life might thrive in places we once thought were inhospitable, from the icy moons of the outer solar system to the subsurface oceans of Enceladus. This shift in thinking isn't just about finding life elsewhere. It's about understanding the incredible adaptability of life itself. If life can exist in such extreme environments, what does that mean for Earth? It suggests that life here might be far more resilient than we realize, capable of enduring even the harshest conditions. The search for extraterrestrial life also raises profound questions about our place in the universe. What would it mean to discover that we're not alone? For some, it might be a humbling reminder of our smallness in the grand scheme of things. For others, it could spark a renewed sense of wonder and curiosity. Astrobiologists often describe this search as a journey of self-discovery. By looking outward, we're also looking inward, questioning what makes life possible and what it means to be alive. It's a quest that blurs the lines between science and philosophy, inviting us to reflect on our own existence. But the implications of this search go beyond philosophy. It's also driving incredible technological innovation. The tools and techniques developed to search for life on other worlds are pushing the boundaries of what's possible. From advanced spectrometers that can detect faint chemical signatures to robotic arms capable of drilling through ice, these technologies are not only helping us explore distant planets, but also improving life here on Earth. For instance, the same instruments used to analyze Martian soil are being adapted for medical diagnostics, while the algorithms that process planetary data are enhancing machine learning and artificial intelligence. This quest is also a testament to the power of human curiosity. It's a reminder that exploration isn't just about reaching new places, it's about asking new questions. What if life exists in the methane seas of Titan? What if microbial communities thrive in the hydrothermal vents of Enceladus? Each mission brings us closer to answering these questions, and with every discovery, we gain a deeper appreciation for the complexity and diversity of the universe. As we continue this search, we're reminded that the answers we find might not be what we expect. They could challenge our assumptions, reshape our perspectives, and even redefine what it means to be human. Whether we discover life elsewhere or not, the journey itself is transforming how we see Earth, not just as a solitary oasis, but as part of a vast, interconnected cosmos teeming with possibilities. And in that transformation, we find not just answers, but a renewed sense of wonder and purpose. This brings us to the next chapter of our exploration: how the technologies and insights gained from the search for extraterrestrial life are shaping the future of science, innovation, and our understanding of the universe itself. Space exploration doesn't just change how we see the universe, it changes how we see ourselves. When we look at Earth from space, we're confronted with a reality that's both humbling and unifying. Our planet, a pale blue dot suspended in the infinite black, becomes a symbol of our shared existence. This cosmic perspective challenges the way we think about identity, not just as individuals or nations, but as a species. It forces us to ask, what does it mean to be human in a universe so vast and mysterious? Carl Sagan, one of the most eloquent voices in science, captured this idea beautifully. In his famous reflection on the pale blue dot image, he wrote, "Look again at that dot, that's here, that's home, that's us." With those words, he distilled the essence of the cosmic perspective, a realization that all of human history, every triumph and tragedy, every culture and civilization, has unfolded on this tiny speck in the cosmos. It's a perspective that shrinks our egos while expanding our sense of connection. Suddenly, the divisions we create, borders, ideologies, conflicts, seem trivial against the backdrop of the universe. Neil deGrasse Tyson has echoed this sentiment, often describing the cosmic perspective as a cosmic humility. He argues that seeing Earth from space doesn't diminish our importance, it redefines it. Instead of seeing ourselves as the center of the universe, we recognize that we're part of something much larger. This shift in worldview isn't just philosophical, it's practical. It reminds us that our challenges, climate change, inequality, conflict, are global issues that require global solutions. We're not just citizens of individual nations, we're citizens of Earth. This profound shift in identity has ripple effects across culture and art. Think about how the Apollo missions inspired a wave of creativity in the late 1960s and 70s. Songs like David Bowie's Space Oddity and films like Stanley Kubrick's 2001, A Space Odyssey captured the awe and introspection that came with seeing Earth from space. These works didn't just reflect the technological achievements of the time, they explored the existential questions that space exploration raises. What does it mean to be human? What is our purpose, and how do we fit into the grand tapestry of the cosmos? Today, this influence continues. Artists and writers draw inspiration from the cosmic perspective to create works that challenge us to think beyond our immediate concerns. Take the Overview Effect series by photographer Benjamin Grant, which uses satellite imagery to show Earth in ways that are both beautiful and thought-provoking. His images remind us of the fragility and interconnectedness of our planet, sparking conversations about sustainability and unity. Similarly, science fiction authors like N.K. Jemisin and Ted Chiang use the cosmic perspective to explore themes of identity, belonging, and humanity's place in the universe. The cosmic perspective also shapes how we think about our future. If we're all part of one global community, then our destiny is shared. This idea has fueled movements for international cooperation, from climate agreements to space exploration partnerships. It's a reminder that while our differences are real, they're also small compared to what unites us. As we venture further into space, this sense of shared destiny will only grow stronger. Missions to the Moon, Mars, and beyond aren't just about scientific discovery. They are about discovering what it means to be human in a universe that's infinitely larger than ourselves. In the end, the cosmic perspective is more than a way of seeing, it's a way of being. It challenges us to think bigger, to care more deeply, and to act with greater purpose. It reminds us that our time on this pale blue dot is fleeting, and that the choices we make today will echo far into the future. Whether we're gazing at the stars or standing on the ground, this perspective invites us to see ourselves not as isolated individuals, but as part of a grand, interconnected story, one that stretches from the dawn of time to the farthest reaches of the cosmos. And as we continue to explore the universe, we'll not only uncover its secrets, we'll uncover more about ourselves. This journey, both outward and inward, is what makes space exploration so profound. It's not just about reaching new horizons, it's about redefining who we are in the process. Space exploration has always been more than a scientific endeavor, it's a cultural force, shaping how we see ourselves and our place in the universe. From the silver screen to the pages of novels, the cosmos has inspired some of the most iconic works of art, literature, and music, capturing the imagination of generations. These cultural expressions don't just reflect our curiosity about the stars, they reveal how the cosmic perspective influences the way we think, dream, and create. Take Stanley Kubrick's 2001, A Space Odyssey, for example. Released in 1968, this groundbreaking film wasn't just a visual masterpiece. It was a philosophical exploration of humanity's relationship with technology, evolution, and the unknown. With its stunning depictions of space travel and its enigmatic monoliths, 2001 challenged audiences to think beyond the confines of Earth. It asked profound questions about our origins, our potential, and our destiny as a species. The film's haunting imagery and thought-provoking narrative left an indelible mark on popular culture, inspiring countless filmmakers, writers, and artists to explore the mysteries of the cosmos. Music, too, has been deeply influenced by space exploration. David Bowie's Space Oddity, released just days before the Apollo 11 moon landing in 1969, captured the zeitgeist of an era captivated by the stars. With its poignant lyrics and haunting melody, the song told the story of Major Tom, an astronaut adrift in space, cut off from Earth. It wasn't just a song, it was a meditation on isolation, connection, and the fragility of human existence. Bowie's fascination with space continued throughout his career, culminating in albums like Ziggy Stardust and songs like Life on Mars that blended science fiction with profound emotional depth. Through his music, Bowie invited listeners to see the universe not just as a place of wonder, but as a mirror reflecting our own hopes, fears, and dreams. These cultural works aren't just entertainment, they are lenses through which we process the profound implications of space exploration. They help us grapple with big questions. What does it mean to venture into the unknown? How do we reconcile our smallness in the cosmos with our desire to explore and understand? And what does the future hold for humanity as we reach for the stars? By weaving these themes into art and music, creators like Kubrick and Bowie have made the cosmic perspective accessible, sparking curiosity and imagination in audiences worldwide. But the influence of space exploration on culture goes beyond individual works. It has shaped entire genres and movements. Science fiction, for instance, has long been a space where writers and filmmakers explore the possibilities of the future. Authors like Isaac Asimov, Ursula K. Le Guin, and Octavia Butler have used the cosmos as a backdrop to examine social, political, and ethical questions. Their stories imagine worlds where humanity has colonized other planets, encountered alien civilizations, or confronted the consequences of technological advancement. These narratives aren't just escapism, they're thought experiments that challenge us to consider the choices we make today and their impact on tomorrow. Even in popular media, space exploration has left its mark. Television shows like Star Trek and Doctor Who have inspired generations with their visions of a future where humanity works together to explore the universe. These stories aren't just about adventure, they're about hope, unity, and the potential for progress. They remind us that the challenges we face, whether on Earth or in space, are opportunities to grow, innovate, and come together. The cultural impact of space exploration also extends to education and public engagement. Museums, planetariums, and science centers around the world use space-themed exhibits to spark curiosity and inspire learning. Programs like NASA Artemis missions and the International Space Station's educational outreach initiatives bring the wonders of space into classrooms, encouraging students to pursue careers in science, technology, engineering, and mathematics. By making space exploration accessible, these efforts help cultivate a new generation of thinkers and dreamers who will carry the torch of discovery forward. In many ways, the cultural evolution driven by space exploration is a testament to the power of creativity. It shows that the cosmos isn't just a place of scientific inquiry, it's a canvas for imagination, a source of inspiration that transcends boundaries. Whether through film, music, literature, or education, the cosmic perspective invites us to see the universe not just as it is, but as it could be. It challenges us to dream bigger, think deeper, and create with purpose, reminding us that the stars are not just destinations, they're catalysts for transformation. As we look to the future, this cultural legacy will continue to shape how we explore the cosmos and understand our place within it. The stories we tell, the art we create, and the questions we ask are all part of a larger conversation, one that bridges the gap between science and humanity and reminds us that the journey to the stars is as much about discovering ourselves as it is about discovering the universe. Space exploration has a unique power to ignite curiosity, especially in young minds. It's not just about rockets and distant planets. It's about opening doors to new possibilities and inspiring the next generation to dream big. Programs like NAS, STEM initiatives are at the forefront of this effort, designed to engage students in science, technology, engineering, and mathematics. Through hands-on projects, interactive workshops, and collaborations with schools, these programs aim to make the wonders of space accessible to everyone, regardless of background or location. They're not just teaching kids about space, they're showing them that they have a role to play in shaping the future of exploration. Take the Artemis generation, for example. Named after NASA's ambitious mission to return humans to the moon, this initiative is inspiring young people to see themselves as the explorers of tomorrow. Students participating in Artemis-related projects aren't just learning about lunar geology or rocket design. They are solving real-world problems, from designing habitats for the moon to developing tools for astronauts. These experiences go beyond textbooks, offering a taste of what it means to work on the cutting edge of science and technology. For many, it's a transformative experience, sparking a lifelong passion for discovery. The cosmic perspective also plays a crucial role in fostering critical thinking and problem-solving skills. When students study space, they're not just memorizing facts, they're learning how to ask questions, analyze data, and think creatively. For instance, virtual reality simulations of space missions allow students to step into the shoes of an astronaut, navigating the challenges of zero gravity or planning a mission to Mars. These immersive experiences don't just make learning fun, they teach valuable skills like teamwork, adaptability, and resilience, qualities that are essential in any field. Stories of young people inspired by space exploration are everywhere. Consider the case of Alyssa Carson, who at just 3 years old declared she wanted to be an astronaut. By her teenage years, she had attended space camps around the world and even earned her pilot's license. Today, she's a vocal advocate for STEM education and a role model for aspiring space explorers. Or take the story of a group of high school students in rural India who built a low-cost satellite to study climate change. Their project, supported by a national space agency, not only advanced scientific research but also proved that innovation knows no boundaries. Educational tools like these are changing the way we teach and learn about space. Virtual reality, augmented reality, and even simple tools like 3D printed models of spacecraft are making complex concepts tangible and engaging. Platforms like NASA Eyes on the Solar System allow students to explore the solar system in real time, while coding competitions challenge them to develop software for space missions. These resources aren't just about sparking interest, they're about equipping young people with the skills they need to tackle the challenges of tomorrow. This inspiration doesn't stop at the classroom. It drives innovation and progress across society. When students are exposed to the possibilities of space exploration, they're more likely to pursue careers in science, engineering, and technology, fields that are critical to solving global challenges like climate change, energy sustainability, and healthcare. The skills they develop through these experiences, critical thinking, creativity, and collaboration, are transferable to any field, making them not just future scientists, but future leaders. As we look to the future, the importance of inspiring the next generation cannot be overstated. The challenges we face both on Earth and in space require bold ideas and fresh perspectives. By nurturing curiosity and providing opportunities for young people to engage with space exploration, we're not just preparing them for the jobs of tomorrow, we're empowering them to shape the future of humanity. And in doing so, we're ensuring that the spirit of exploration continues to thrive, not just in the stars, but in the hearts and minds of every generation to come. The ripple effects of this inspiration are already being felt, from classrooms to labs to launch pads. And as we continue to explore the cosmos, we're reminded that the most important discoveries aren't just about what we find out there, they're about who we become in the process. When we think about space exploration, it's easy to focus on the scientific breakthroughs or the awe-inspiring images of distant galaxies. But there's another dimension to this journey, one that's closer to home and deeply intertwined with our daily lives: the economy. Space exploration isn't just about reaching the stars. It's a powerful engine for economic growth and technological progress. From the rise of the commercial space industry to the countless ways satellite technology has transformed our world, the economic impact of space exploration is both vast and far-reaching. Consider the commercial space sector, which has exploded in recent years. Companies like SpaceX and Blue Origin are no longer just players in a government-led space race, they're pioneers of a new era. SpaceX's reusable rockets, for example, have dramatically reduced the cost of launching payloads into orbit, making space more accessible than ever before. This innovation hasn't just benefited space missions, it's created thousands of jobs, spurred investment, and inspired a wave of startups aiming to capitalize on the opportunities in space. The commercial space industry is now worth hundreds of billions of dollars, and it's growing faster than ever, proving that the final frontier isn't just a place of discovery, it's a booming marketplace. But the economic benefits of space exploration extend far beyond the launch pad. Satellite technology, once the domain of governments and large corporations, has become a cornerstone of modern life. Think about the last time you used GPS to navigate, streamed a live event, or checked the weather forecast. These everyday conveniences are powered by satellites orbiting high above Earth. The global satellite industry alone generates over $200 billion annually, supporting industries from agriculture to telecommunications. Farmers use satellite data to optimize crop yields, while disaster response teams rely on it to coordinate relief efforts. Even the internet you're using right now might be beamed down from space, thanks to advancements in satellite broadband. Space exploration also drives innovation in fields you might not immediately associate with rockets or astronauts. Take materials science, for instance. The extreme conditions of space demand materials that are lightweight, durable, and able to withstand intense heat and radiation. These advancements don't just stay in space, they find their way into everyday products. Memory foam, developed for NASA's spacecraft seats, is now a staple in mattresses and pillows. Scratch-resistant coatings, originally created for astronaut visors, protect our smartphones and eyeglasses. Even the water filtration systems used on the International Space Station have inspired technologies that provide clean drinking water in remote areas on Earth. Robotics is another area where space exploration has sparked groundbreaking progress. The rovers exploring Mars, like NASA Perseverance, are marvels of engineering, equipped with advanced sensors and autonomous navigation systems. These technologies are now being adapted for use in industries like manufacturing, healthcare, and even disaster response. Imagine a robot performing delicate surgeries with the precision of a Mars rover, or navigating disaster zones to locate survivors. These aren't just futuristic ideas, they're real-world applications of space-driven innovation. Energy is yet another sector transformed by space exploration. Solar panels, initially developed to power spacecraft, are now a key component of the global push toward renewable energy. Innovations in battery technology, driven by the need for efficient energy storage in space, are revolutionizing how we power everything from electric cars to homes. The ripple effects of these advancements are profound, creating jobs, reducing our reliance on fossil fuels, and helping to combat climate change. But as we celebrate these economic and technological triumphs, it's important to ask, what are the ethical implications of space exploration? Who gets to benefit from these advancements, and who might be left behind? The commercialization of space raises questions about equity and access. Should the resources of the cosmos be available to all, or will they become the domain of a privileged few? These are complex issues that demand thoughtful consideration as we venture further into the stars. The economic impact of space exploration is a testament to the power of human ingenuity. It shows that the pursuit of knowledge isn't just a noble endeavor, it's a practical one with tangible benefits for our lives and economies. As we continue to explore the cosmos, we're not just reaching for the stars, we're building a better future here on Earth, one innovation at a time. And in this journey, we're reminded that the final frontier isn't just a place to visit, it's a source of endless possibility, driving progress and prosperity for generations to come. As we venture further into the cosmos, we're confronted with questions that go beyond science and technology, questions that touch on the very essence of what it means to be human. Space exploration isn't just about what we can do, it's about what we should do. The ethical dilemmas we face as we reach for the stars are as vast and complex as space itself. Who owns the moon? How do we ensure that the benefits of space exploration are shared equitably? And what responsibilities do we have to protect the celestial environments we're only beginning to explore? These questions aren't hypothetical. As private companies and nations alike set their sights on mining asteroids or establishing lunar bases, the issue of resource exploitation has become a pressing concern. The moon, for instance, is rich in rare minerals like helium-3, which could revolutionize energy production on Earth, but who has the right to extract these resources? If one nation or corporation claims ownership, does that exclude others? These debates aren't just about legality, they are about fairness, sustainability, and the values we want to carry into space. The Outer Space Treaty of 1967 offers some guidance. This landmark agreement, signed by over 100 countries, declares that space is the province of all mankind and prohibits any nation from claiming sovereignty over celestial bodies. But as technology advances and the stakes grow higher, the treaty's limitations are becoming apparent. It doesn't explicitly address commercial activities or resource extraction, leaving gray areas that ethicists and policymakers are now grappling with. Some argue that we need new frameworks to ensure that space exploration benefits everyone, not just the few with the means to get there. One of the most thought-provoking scenarios involves Mars. If humanity establishes a permanent settlement on the Red Planet, how do we govern it? Will it be a colony of Earth, subject to the laws and interests of a particular nation? Or will it evolve into an independent society, free to chart its own course? These aren't just philosophical musings, they're questions with real-world implications. The choices we make today will shape the future of space exploration for generations to come. Ethicists like Dr. Lucian Wakovich, an astrophysicist and advocate for responsible space exploration, emphasize the importance of foresight. She argues that we must approach space with humility and a commitment to stewardship, recognizing that our actions there will have lasting consequences. We have a chance to do things differently in space, she says, to learn from the mistakes we've made on Earth and create a future that's more just and sustainable. Balancing progress with responsibility is no small task. On one hand, space exploration has the potential to drive innovation, solve global challenges, and unite humanity in a shared endeavor. On the other, there's a risk of repeating the mistakes of our past exploitation, inequality, and environmental degradation. How do we navigate this tension? Some suggest that international collaboration is key. By working together, nations can ensure that space exploration benefits all of humanity, not just a privileged few. Others advocate for greater public involvement, empowering communities to have a say in how space is used and governed. These conversations aren't just happening in boardrooms or academic circles, they're unfolding in the public sphere, where people from all walks of life are weighing in on the future of space exploration. From social media debates to grassroots movements, there's a growing recognition that space isn't just the domain of scientists and engineers. It's a shared heritage that belongs to everyone. This collective engagement is crucial because the decisions we make about space will shape not just our future in the cosmos, but our identity as a species. Space exploration challenges us to think bigger not just about the stars, but about ourselves. It forces us to confront our biases, our assumptions, and our responsibilities. As we look to the future, we're reminded that the journey into space isn't just about reaching new destinations. It's about becoming better stewards of our planet and better custodians of our shared humanity. The ethical questions we face today are an invitation to imagine a future that's not only technologically advanced, but also just, equitable, and compassionate. And in that vision, we find the true promise of the cosmic perspective. This brings us to the next chapter of our exploration: how the ethical frameworks we build today will shape the legacy we leave for tomorrow, both on Earth and among the stars. The future of space exploration isn't just about reaching new worlds, it's about redefining what's possible for humanity. Imagine a world where lunar bases serve as stepping stones to the stars, where humans walk on Mars, and where the lessons we learn from space help us tackle some of the most pressing challenges here on Earth. These aren't just dreams, they're tangible goals that scientists, engineers, and visionaries are working toward right now. And as we push the boundaries of exploration, we're not just expanding our horizons, we're transforming how we see ourselves and our place in the universe. One of the most immediate goals is establishing a sustainable presence on the Moon. NASA's Artemis program aims to land the first woman and the next man on the lunar surface by the mid-2020s, with plans to build a long-term habitat that could support future missions. This isn't just about planting flags and taking photos, it's about creating a blueprint for living and working in space. A lunar base could serve as a testing ground for technologies like 3D printed habitats, advanced life support systems, and resource extraction techniques. It could also become a hub for scientific research, offering insights into the Moon's geology, the effects of low gravity on the human body, and even the origins of our solar system. But the Moon is just the beginning. Mars looms large in the collective imagination as the next great frontier. Sending humans to the Red Planet is no small feat. It requires overcoming immense technical, logistical, and psychological challenges. Yet, the potential rewards are staggering. A successful mission to Mars could revolutionize our understanding of planetary science, offering clues about the possibility of past or present life. It could also pave the way for future colonization, providing a backup plan for humanity in the event of a catastrophic event on Earth. Visionaries like Elon Musk and organizations like SpaceX are already working on ambitious plans to make Mars colonization a reality, with timelines that stretch into the next few decades. These endeavors aren't just about exploration, they are about survival. Earth's resources are finite, and as our population grows, so do the pressures on our planet's ecosystems. Space exploration offers a potential solution to some of these challenges. Asteroids, for example, are rich in precious metals and rare minerals that could alleviate resource scarcity. The Moon's polar ice could provide water for drinking, agriculture, and even rocket fuel, reducing the need to launch costly payloads from Earth. By tapping into these extraterrestrial resources, we could create a more sustainable future for humanity, both on and off our home planet. The cosmic perspective also has the power to unite us in ways we've never experienced before. Imagine a world where nations collaborate not just on Earth, but in space, pooling their resources and expertise to achieve shared goals. The International Space Station is a shining example of what's possible when we work together, and future missions to the Moon and Mars could build on this legacy. By transcending borders and embracing a sense of global citizenship, we could tackle challenges like climate change, overpopulation, and inequality with renewed vigor and creativity. Futurists and scientists have painted vivid pictures of what this future might look like. Some envision a humanity that is spread across the solar system, with thriving colonies on Mars, mining operations in the asteroid belt, and even interstellar missions to nearby star systems. Others imagine a world where space-based technologies have transformed life on Earth, from asteroid mining to space-based solar power. These speculative scenarios aren't just science fiction, they're invitations to dream, to imagine a future where the boundaries of what's possible are continually pushed further. But perhaps the most profound impact of space exploration lies in how it changes us. The cosmic perspective reminds us that we're all passengers on a tiny, fragile spaceship hurtling through the void. It challenges us to think beyond our immediate concerns and consider the long-term consequences of our actions. It inspires us to see Earth not as a collection of competing nations, but as a single, interconnected system that we must protect and cherish. And it offers hope, a reminder that even in the face of immense challenges, humanity has the capacity to innovate, collaborate, and thrive. As we look to the stars, we're reminded that the future isn't something that happens to us, it's something we create. The choices we make today, from how we explore space to how we care for our planet, will shape the destiny of generations to come. And in that journey, we find not just the promise of discovery, but the enduring power of the cosmic perspective to inspire, unite, and transform. This brings us to the next chapter, how the lessons we learn from space exploration can guide us in building a future that's not only technologically advanced, but also just, equitable, and sustainable for all. As we venture further into the cosmos, one of the most transformative tools at our disposal isn't a rocket or a telescope, it's artificial intelligence. AI is revolutionizing space exploration, reshaping how we gather, analyze, and interpret the vast amounts of data that flow from satellites, rovers, and telescopes. From autonomous robots navigating alien landscapes to algorithms that sift through petabytes of Earth observation data, AI is becoming an indispensable partner in our quest to understand the universe and our place within it. One of the most exciting applications of AI is in the realm of autonomous space exploration. Take NASA Perseverance rover, for example. This robotic explorer, currently roaming the surface of Mars, relies on AI to make decisions in real time. Its autonomous navigation system allows it to analyze terrain, avoid obstacles, and plot the safest path forward, all without human intervention. This isn't just about convenience, it's about efficiency. By reducing the time it takes to relay instructions from Earth, AI enables rovers to cover more ground, gather more data, and make discoveries faster than ever before. It's as if the rover has a mind of its own, one that's constantly learning and adapting to the challenges of an alien world. But AI's role in space exploration goes far beyond robotics. It's also transforming how we process and interpret the massive amounts of data generated by satellites and telescopes. Every day, Earth-observing satellites capture terabytes of information about our planet, everything from cloud formations and ocean currents to deforestation and urban sprawl. Analyzing this data manually would be an impossible task, but AI thrives on it. Machine learning algorithms can identify patterns and trends that would be invisible to the human eye, uncovering insights that help us better understand Earth's complex systems. For instance, AI is now being used to predict weather patterns with unprecedented accuracy. By analyzing historical data and real-time observations, these algorithms can forecast everything from hurricanes to heat waves, giving communities more time to prepare and respond. Similarly, AI is helping scientists track environmental changes, such as the melting of polar ice caps or the spread of wildfires. These tools aren't just providing data, they're offering actionable insights, empowering policymakers and conservationists to make informed decisions that protect our planet. The potential of AI extends beyond Earth as well. In the search for extraterrestrial life, AI is helping scientists sift through the noise to find potential signals of life. The SETI Institute, for example, uses machine learning to analyze radio signals from distant stars, filtering out natural phenomena to focus on those that might have intelligent origins. While we haven't found definitive proof of life beyond Earth yet, AI is making the search more efficient and targeted, bringing us closer to answering one of humanity's most profound questions. Experts in the field are optimistic about AI's future in space science. Dr. Claire Andrioli, a NASA spokesperson, describes AI as a game changer that's enabling us to do more science faster and with greater precision than ever before. Similarly, Dr. Fei Lai, a leading AI researcher, highlights how these technologies are bridging the gap between data and discovery, transforming raw information into meaningful knowledge. What makes AI so powerful is its ability to connect the dots between space exploration and Earth-based challenges. The same algorithms that help us explore Mars are also being used to address issues like climate change, disaster response, and resource management. For example, AI-driven satellite imagery is helping farmers optimize irrigation, reduce pesticide use, and increase crop yields. In disaster zones, AI analyzes satellite data to identify the hardest-hit areas, guiding relief efforts and saving lives. These applications show that the lessons we learn in space aren't just about the stars, they're about improving life here on Earth. As we look to the future, the role of AI in space exploration will only continue to grow. From designing smarter spacecraft to uncovering the secrets of distant galaxies, artificial intelligence is poised to become an essential tool in our cosmic toolkit. And as we harness its power, we're reminded that the journey into space isn't just about reaching new frontiers. It's about using the tools we develop along the way to solve the challenges that matter most, both in the cosmos and at home. This seamless integration of AI into space science highlights a profound truth. The tools we create to explore the universe often end up transforming our understanding of Earth itself. And in that transformation, we find new ways to protect, nurture, and sustain the only home we've ever known. Space exploration has always been about pushing boundaries, not just in the cosmos, but in improving life here on Earth. One of the most profound and unexpected benefits of venturing into space is its impact on global health. The challenges of living and working in the extreme environment of space have driven innovations that are now saving lives and transforming healthcare in ways we couldn't have imagined just a few decades ago. From cutting-edge medical technologies to groundbreaking research on human physiology, the ripple effects of space exploration are felt in hospitals, clinics, and even the most remote corners of our planet. Consider telemedicine, a field that has seen remarkable advancements thanks to space exploration. On the International Space Station, astronauts often face medical emergencies far from Earth's hospitals. To address this, NASA developed sophisticated telemedicine systems that allow doctors on the ground to remotely diagnose and guide treatments in real time. These systems rely on high-resolution imaging, advanced sensors, and secure communication technologies tools that have since been adapted for use on Earth. Today, telemedicine is revolutionizing healthcare in rural and underserved areas, bringing expert medical care to people who would otherwise have limited access. It's a perfect example of how solving problems in space can have life-changing applications here at home. Another space-inspired innovation is the development of portable diagnostic tools. In the weightless environment of space, traditional medical equipment is often impractical. This led to the creation of compact, lightweight devices that can perform complex diagnostics with minimal resources. Devices like handheld ultrasound machines, originally designed for use on the ISS, are now being used in disaster zones, remote villages, and even ambulances. These tools are not only saving lives, but also making health care more accessible and efficient, proving that the lessons learned in space can address some of the most pressing health challenges on Earth. The study of human physiology in microgravity has also opened new doors for medical research. In space, the absence of gravity causes dramatic changes in the human body, from muscle atrophy and bone density loss to fluid shifts that affect vision and brain function. While these changes pose challenges for astronauts, they also provide a unique opportunity to study the human body in ways that aren't possible on Earth. For instance, research on bone loss in space has led to breakthroughs in understanding and treating osteoporosis, a condition that affects millions of people worldwide. Similarly, studies on fluid redistribution in microgravity are shedding light on conditions like glaucoma and intracranial pressure, offering new avenues for treatment. One of the most impactful space-inspired innovations is water filtration technology. On the ISS, every drop of water is precious, leading to the development of advanced systems that can recycle wastewater into clean, drinkable water. These systems have been adapted for use in remote and disaster-stricken areas, providing safe drinking water to communities in need. In places where access to clean water is a daily struggle, this technology is more than a convenience, it's a lifeline. It's a powerful reminder that the solutions we create for space exploration can address some of the most fundamental challenges facing humanity. Case studies further illustrate the real-world impact of these innovations. Take, for example, the collaboration between NASA and the World Health Organization to combat infectious diseases. Satellite data, combined with AI algorithms, is now being used to track and predict the spread of diseases like malaria and dengue fever. By monitoring environmental factors such as temperature, rainfall, and vegetation, scientists can identify high-risk areas and target interventions more effectively. This approach has already saved countless lives, demonstrating how space technology can be a game-changer in the fight against global health crises. But perhaps the most profound lesson space exploration teaches us is resilience. Living in space requires adaptability, problem-solving, and a willingness to confront the unknown qualities that are equally essential in addressing global health challenges. The same mindset that enables astronauts to thrive in the harsh environment of space can inspire us to tackle problems like pandemics, climate-related health risks, and healthcare disparities. Space exploration reminds us that even the most daunting challenges can be overcome with innovation, collaboration, and determination. As we continue to explore the cosmos, the benefits to global health will only grow. From telemedicine to water filtration, from medical research to disease prevention, the technologies and insights gained from space exploration are transforming how we care for one another. And in this journey, we're reminded that the pursuit of knowledge isn't just about reaching new frontiers. It's about improving life for everyone, everywhere. Space exploration isn't just a physical journey, it's a psychological one. For astronauts, The experience of leaving Earth and venturing into the unknown is as much about confronting their own minds as it is about mastering the mechanics of spaceflight. From the profound isolation of long-duration missions to the overwhelming awe of seeing Earth from space, the psychological impact of space exploration is both profound and transformative. These experiences don't just shape the individuals who live them, they ripple out, influencing how we all see ourselves and our place in the universe. One of the most significant psychological challenges astronauts face is isolation. Imagine being confined to a spacecraft or space station for months, even years, with limited contact with loved ones and the constant hum of machinery as your only companion. The psychological toll of this isolation can be immense. Studies have shown that prolonged periods of confinement and separation can lead to feelings of loneliness, depression, and even cognitive decline. Astronauts must navigate these challenges while also performing complex tasks in a high-stakes environment where even small mistakes can have catastrophic consequences. It's a mental marathon that requires resilience, adaptability, and a deep well of emotional strength. To combat these challenges, space agencies have developed a range of strategies to support astronauts' mental health. Regular communication with family and friends through video calls helps maintain a sense of connection to Earth. Structured routines, including exercise and leisure activities, provide a sense of normalcy and purpose. Psychologists also work closely with astronauts before, during, and after missions, offering tools to manage stress and maintain emotional well-being. For example, mindfulness and meditation techniques have become increasingly popular among astronauts, helping them stay grounded and focused in the face of isolation and uncertainty. But it's not all about coping with challenges. Space exploration also offers profound psychological benefits, particularly through the awe-inspiring experience of seeing Earth from space. Known as the overview effect, this phenomenon has been described by astronauts as a life-changing shift in perspective. From orbit, the boundaries and divisions that seem so important on the ground, borders, nations, conflicts fade away, replaced by a profound sense of unity and interconnectedness. Astronauts often return to Earth with a renewed appreciation for our planet and a deep commitment to protecting it. This emotional transformation isn't just anecdotal. Psychologists have studied the overview effect and its potential to foster empathy, humility, and a greater sense of purpose. Consider the story of astronaut Scott Kelly, who spent nearly a year aboard the International Space Station. During his mission, Kelly documented his experiences through photos and journal entries, capturing the beauty of Earth and the emotional highs and lows of life in space. In his memoir, he describes how the experience changed him, not just as an astronaut but as a person. Seeing Earth from space makes you realize how small and fragile it is, he writes. It's a perspective that stays with you long after you return. Kelly's story is just one example of how space exploration can reshape not only our understanding of the universe, but also our understanding of ourselves. Psychologists have also explored how the cosmic perspective can benefit those of us who never leave Earth. Studies suggest that reflecting on the vastness of the universe can reduce stress, increase feelings of awe, and even boost creativity. This is why images and videos from space like the iconic blue marble photo or the mesmerizing footage of Earth's auroras resonate so deeply with people. They remind us that we're part of something much larger than ourselves, offering a sense of perspective that can be both humbling and uplifting. These psychological insights have far-reaching implications, not just for astronauts, but for all of humanity. As we continue to explore space, the lessons we learn about resilience, connection, and perspective can help us navigate the challenges we face here on Earth. Whether it's finding new ways to cope with isolation or cultivating a deeper appreciation for our shared home, the psychological journey of space exploration is a reminder of our capacity for growth and transformation. The emotional and psychological impact of space exploration doesn't just shape individuals, it shapes our collective consciousness. It challenges us to think beyond our immediate concerns and consider the broader implications of our actions. It inspires us to see ourselves not as isolated beings, but as part of a global community united by our shared humanity and our shared home. And in this shift in perspective, we find the true power of space exploration, not just to take us to new worlds, but to help us see our own world and ourselves in a new light. This brings us to the next chapter: how the psychological insights gained from space exploration are influencing fields like education, leadership, and even conflict resolution, offering new ways to address the challenges of life on Earth. Space exploration has always been more than a scientific endeavor. It's a quest for meaning. For centuries, humanity has looked to the stars not just to understand the universe, but to understand ourselves. The vastness of the cosmos forces us to confront questions that have no easy answers. Why are we here? What is our purpose? And what does it mean to exist in a universe so unimaginably large and complex? These questions aren't just philosophical musings, they're at the heart of why we explore. Space exploration, in many ways, is humanity's way of searching for answers to the deepest mysteries of existence. From a philosophical standpoint, the cosmic perspective challenges our assumptions about life and our place in the universe. Theologians and philosophers have long grappled with the idea of humanity's significance in the grand scheme of things. Some argue that the sheer scale of the cosmos diminishes our importance, reducing us to mere specks in an infinite void. Others, however, see it differently. They argue that the very fact we can contemplate the universe, that we can explore it and seek to understand it, gives our existence profound meaning. As Carl Sagan once put it, we are a way for the cosmos to know itself. In this view, space exploration isn't just a journey outward, it's a journey inward, a way for us to reflect on what it means to be human. Scientists, too, have weighed in on this search for meaning. Astrophysicist Neil deGrasse Tyson often speaks about how the cosmic perspective can shift our worldview. The universe is under no obligation to make sense to you, he says, emphasizing that our understanding is constantly evolving. Yet, this very uncertainty is what drives us to explore, to push the boundaries of knowledge and discover truths that may redefine our sense of purpose. For many scientists, the act of discovery itself is a source of meaning, a way to contribute to something far greater than any one individual. Metaphors can help illustrate the profound impact of this perspective. Imagine the universe as a vast, uncharted ocean. Each star is an island, each galaxy a distant archipelago. We, as explorers, are setting sail into the unknown, not just to map the waters, but to find out why the ocean exists at all. This metaphor captures the dual nature of space exploration. It's both a physical journey and a spiritual one. It's about charting new territories while also seeking to understand why those territories exist in the first place. Theologians have also found rich ground for reflection in the cosmic perspective. Many religious traditions see the universe as a manifestation of divine creativity, a canvas on which the sacred has painted its masterpiece. For these thinkers, space exploration isn't just a scientific pursuit, it's a form of worship, a way to marvel at the intricacies of creation. This view doesn't necessarily conflict with science, rather, it complements it, offering a framework for understanding the awe and wonder that space inspires. In this sense, the search for meaning becomes a dialogue between faith and reason, each offering its own insights into the mysteries of existence. But perhaps the most powerful aspect of the cosmic perspective is its ability to inspire hope and optimism. In a world often divided by borders, ideologies, and conflicts, space exploration reminds us of our shared humanity. When we look at Earth from space, we see a fragile, beautiful world, one that belongs to all of us. This vision has the power to unite, to remind us that our differences are small compared to the vastness of the cosmos. It's a perspective that encourages us to think beyond our immediate concerns and imagine a future where we work together to explore, to discover, and to thrive. This sense of hope is not just abstract, it's tangible. Every mission to the stars is a testament to what we can achieve when we collaborate, when we dare to dream big. The Apollo missions, the International Space Station, and the upcoming Artemis program are all examples of humanity's capacity for greatness. They show us that even in the face of immense challenges, we can reach for the stars, and in doing so, we can find not just answers, but a renewed sense of purpose. As we continue to explore the cosmos, we're reminded that the search for meaning is not just about finding answers, it's about asking the right questions. It's about embracing the unknown, celebrating the journey, and finding beauty in the mysteries that remain. Space exploration, in this sense, is more than a scientific endeavor. It's a deeply human one, a way for us to connect with something greater than ourselves. And in that connection, we find not just meaning, but hope for the future, a future where we continue to explore, to dream, and to discover. This brings us to the next chapter of our journey, how the lessons we learn from space exploration can guide us in building a future that's not only technologically advanced, but also deeply meaningful and united in purpose. Space exploration isn't just the domain of astronauts and scientists in lab coats, it's a field where anyone, anywhere can play a part. Thanks to the rise of citizen science projects, ordinary people are contributing to groundbreaking discoveries, proving that you don't need a PhD to help unravel the mysteries of the cosmos. These initiatives, which invite the public to analyze data, identify patterns, and even make discoveries, are transforming how we explore the universe. It's a powerful reminder that space exploration belongs to all of us, and that every contribution, no matter how small, can have a big impact. One of the most well-known platforms for citizen science is Zooniverse, an online hub where volunteers can participate in real scientific research. Projects range from classifying galaxies to identifying craters on the moon, and the data analyzed by these volunteers has led to some remarkable discoveries. For instance, in 2017, a retired schoolteacher named Hanny Van Arkel made headlines when she discovered a never-before-seen cosmic phenomenon while classifying galaxies on Zooniverse. Dubbed Hanny's Voorwerp, this mysterious green blob turned out to be a rare type of quasar ionization echo, a discovery that has since sparked new research into the behavior of supermassive black holes. Stories like Hanny's show that curiosity and dedication can lead to breakthroughs, no matter your background. But it's not just about individual achievements. Citizen science thrives on collective effort. Take the search for exoplanets, for example. NASA Planet Hunters project invites volunteers to sift through data from the Kepler Space Telescope, looking for the telltale dips in starlight that indicate a planet passing in front of its host star. Thanks to the efforts of thousands of volunteers, dozens of exoplanets have been identified, including some that may have conditions suitable for life. This collaborative approach not only accelerates the pace of discovery, but also fosters a sense of shared ownership and excitement about space exploration. Another fascinating example is the SETI at Home project, which harnesses the power of idle home computers to search for signs of extraterrestrial intelligence. By donating their computers' processing power, participants help analyze radio signals from space, contributing to one of the most ambitious scientific quests of our time. While the search for extraterrestrial life is still ongoing, projects like SETI at Home demonstrate how technology can bring people together in the pursuit of knowledge, creating a global network of citizen scientists united by a common goal. The impact of these contributions goes beyond individual discoveries. Citizen science democratizes access to science, breaking down barriers and inviting people from all walks of life to engage with the cosmos. It's a way to make the vast, often intimidating field of space exploration more approachable and inclusive. For many, participating in these projects is more than just a hobby. It's a way to connect with the universe and feel like a part of something bigger. Whether you're a student, a retiree, or someone simply curious about the stars, there's a place for you in the world of citizen science. Take the story of Robert Gagliano, an amateur astronomer who discovered a supernova explosion while analyzing images from a robotic telescope network. His discovery, made possible by a platform called the Catalina Sky Survey, not only contributed to our understanding of stellar evolution, but also inspired countless others to get involved in astronomy. Stories like Robert's highlight the power of passion and persistence, showing that you don't need to be a professional to make a meaningful contribution to science. Citizen science also has a ripple effect on education and public engagement. By involving people in real research, these projects spark curiosity and inspire the next generation of scientists, engineers, and explorers. They show that science isn't just something that happens in labs or universities. It's a dynamic, collaborative process that anyone can be a part of. This sense of participation and inclusion is vital in an era where scientific literacy and public trust in science are more important than ever. As we continue to explore the cosmos, the role of citizen science will only grow. With the advent of more powerful telescopes, satellites, and data collection tools, the volume of information being generated is staggering. Scientists simply can't analyze it all on their own, and that's where the public comes in. By harnessing the collective power of curious minds around the world, we can uncover new insights, solve complex problems, and deepen our understanding of the universe. This democratization of science is one of the most exciting aspects of space exploration. It reminds us that the stars aren't just for a select few, they are for everyone. And in this shared endeavor, we find not just new discoveries, but a renewed sense of connection and purpose. Whether you're classifying galaxies, searching for exoplanets, or simply marveling at the wonders of the cosmos, you're part of a grand, collective journey, one that's reshaping how we see the universe and our place within it. This brings us to the next chapter, how the tools and technologies developed for space exploration are not only advancing science, but also transforming everyday life in ways we might not expect. Space exploration has always been a wellspring of inspiration, not just for scientists and engineers, but for artists of all kinds. From the haunting melodies of David Bowie's Space Oddity to the surreal landscapes of 2001, A Space Odyssey, the cosmos has sparked creativity across every medium, blending the boundaries between art and science. This intersection isn't just about aesthetics, it's about storytelling, emotion, and the human need to make sense of the infinite. Art, in its many forms, becomes a bridge, a way to translate the awe and mystery of space into something tangible, something we can feel. Music, for instance, has long been a vessel for cosmic wonder. Composers like Gustav Holst, with his iconic The Planet Suite, have used sound to evoke the grandeur of the solar system. More recently, bands like Muse and artists like Janelle Monáe have woven space themes into their lyrics and visuals, creating entire albums that feel like odysseys through the stars. Even classical music has embraced the cosmos, with contemporary pieces like John Luther Adams' Become Ocean and Become Desert evoking the vast, otherworldly beauty of the universe. These works don't just entertain, they invite listeners to imagine themselves as part of something much larger, something beyond the confines of Earth. Visual artists, too, have found endless inspiration in the cosmos. Take the works of Agnes Pelton, an early 20th century painter whose abstract pieces often depicted celestial themes, blending spiritual and scientific ideas. Or consider the modern installations of artists like Olafur Eliasson, whose immersive light sculptures mimic the auroras and nebulae of space, transforming galleries into portals to other worlds. Even street art has embraced the cosmic, with murals of galaxies and astronauts popping up in cities around the globe, reminding passers-by to look up and dream. Literature has also been profoundly shaped by space exploration. From the visionary works of Jules Verne and H.G. Wells to the poetic prose of Carl Sagan's Cosmos, writers have used the cosmos as a canvas to explore themes of discovery, identity, and the human condition. Science fiction, in particular, has thrived in this space, with authors like Octavia Butler, Ursula K. Le Guin, and Kim Stanley Robinson imagining futures where humanity grapples with its place in the universe. These stories aren't just escapism, they're thought experiments, challenging us to consider the ethical, social, and philosophical implications of space exploration. Performance art, too, has embraced the cosmic, the overview effect, the profound shift in perspective experienced by astronauts, has inspired theatrical productions and dance performances that explore themes of interconnectedness and fragility. One striking example is the Earthrise experience, a multimedia installation that combines virtual reality with live performance, allowing audiences to see Earth from space and feel the emotional impact of that perspective. These performances aren't just art, they're experiences designed to spark reflection and empathy. But perhaps the most powerful aspect of this creative intersection is how it brings science and art together. Artists often collaborate with scientists to create works that are both beautiful and informative. For example, NASA Visions of the Future posters, which imagine tourism on distant planets, blend rigorous scientific research with stunning graphic design. Similarly, the Golden Record, carried aboard the Voyager spacecraft, is a testament to the power of collaboration. This collection of sounds and images, meant to represent humanity to potential extraterrestrial listeners, is both a scientific artifact and a work of art, a snapshot of our species, frozen in time. The cosmic perspective doesn't just inspire artists, it transforms how they create. Many artists describe how contemplating the vastness of space shifts their approach to their work, encouraging them to think bigger, take risks, and embrace the unknown. This mindset is evident in the works of contemporary creators like Trevor Paglen, whose photography explores the intersection of surveillance, technology, and space. His series, The Last Pictures, features images etched onto a silicon disk and launched into orbit, a work that questions humanity's legacy and our relationship with the cosmos. This blending of art and science isn't just about creating beautiful things, it's about fostering a deeper connection to the universe. Art has the unique ability to communicate complex ideas in ways that resonate emotionally, making the abstract tangible and the distant personal. It's why a painting of a galaxy can evoke a sense of wonder, or a song about the stars can make us feel small yet connected. In this way, art becomes a tool for understanding, a way to process the enormity of space and our place within it. As we continue to explore the cosmos, the role of art in this journey will only grow, whether through films that inspire the next generation of astronauts, music that captures the awe of the overview effect, or installations that bring the stars down to Earth. Art reminds us that space exploration isn't just a scientific endeavor, it's a deeply human one. It's a way to dream, to question, and to connect, bridging the gap between the known and the unknown, the tangible and the infinite. And in that connection, we find not just beauty, but meaning, a reminder that the stars are not just destinations, but mirrors, reflecting our hopes, fears, and boundless curiosity. This brings us to the next chapter, how the tools and technologies of space exploration are not only advancing science, but also shaping the future of creativity itself, opening new possibilities for how we express and understand the universe. When we think of space exploration, names like Neil Armstrong and Yuri Gagarin often come to mind, but the story of humanity's journey to the stars is incomplete without recognizing the trailblazing women who have shaped this field. From the first woman to orbit Earth to the scientists and engineers pushing the boundaries of discovery today, women have played a pivotal role in space exploration, often overcoming immense challenges to do so. Their contributions are not just footnotes in history, they are transformative chapters that have redefined what's possible. It all began with Valentina Tereshkova, a Soviet cosmonaut who made history in 1963 as the first woman to travel to space. At just 26 years old, Tereshkova orbited Earth 48 times aboard Vostok 6, proving that space was not a frontier reserved for men. Her mission was a milestone, but it also highlighted the barriers women faced in the field. For decades, space programs were dominated by men, and women like Tereshkova had to fight for recognition and opportunity. Despite these challenges, her legacy inspired generations of women to reach for the stars. Fast forward to today, and women are breaking barriers in every aspect of space exploration. Take Peggy Whitson, for example, who holds the record for the most cumulative days spent in space by any NASA astronaut. During her career, she not only conducted groundbreaking research aboard the International Space Station, but also became the first woman to command the ISS twice. Her achievements are a testament to the resilience and determination of women in a field that has often underestimated their potential. Behind the scenes, women scientists and engineers are driving innovation in ways that often go unnoticed. Katherine Johnson, whose calculations were critical to the success of NASA's early manned missions, is one such example. Her story, popularized by the film Hidden Figures, sheds light on the countless women of color who contributed to space exploration despite facing systemic discrimination. Johnson's work not only helped land astronauts on the moon, but also paved the way for future generations of women in STEM. The challenges women have faced in space exploration are not just historical, they persist today. Women astronauts still grapple with outdated equipment designed for male bodies, from ill-fitting spacesuits to spacecraft layouts that don't account for their needs. Yet, progress is being made. NASA Artemis program, which aims to land the first woman on the moon, represents a significant step toward gender equality in space. By prioritizing inclusivity, Artemis is not just a mission to the moon, it's a mission to redefine who gets to explore the cosmos. Diversity in space exploration isn't just about fairness, it's about innovation. Research shows that diverse teams are more creative and effective at solving complex problems. When women and people from underrepresented groups are included, space science benefits from a wider range of perspectives and ideas. This is evident in projects like the James Webb Space Telescope, where women engineers and scientists have played key roles in designing and operating one of the most advanced observatories ever built. Stories of women in space exploration are not just inspiring, they're transformative. Consider Jessica Watkins, the first Black woman to complete a long-duration mission on the ISS. Her presence in space is a powerful symbol of progress, showing young girls, especially girls of color, that they too belong among the stars. Similarly, figures like Mae Jemison, the first African-American woman in space, and Kalpana Chawla, the first woman of Indian origin to travel to space, have become symbols of resilience and possibility. The progress made toward gender equality in space exploration is a reminder of how far we've come and how far we still have to go. By celebrating the achievements of women and addressing the barriers they face, we're not just advancing space science, we're creating a more inclusive future for all. This shift toward inclusivity isn't just happening in space agencies. It's reflected in the growing number of women pursuing careers in STEM, inspired by the trailblazers who came before them. As we look to the future, the role of women in space exploration will only continue to grow. From leading missions to designing the next generation of spacecraft, women are proving that the cosmos is a place for everyone. Their stories remind us that diversity isn't just a goal, it's a strength, one that will drive innovation and discovery for generations to come. And in this journey, we find not just progress, but a vision of space exploration that truly reflects the richness of humanity. This forward momentum sets the stage for the next chapter of our exploration, how the lessons we learn from space about inclusivity, resilience, and collaboration can inspire us to build a better future here on Earth. Space exploration has often been framed as a story of technological triumph, but there's another narrative woven into its fabric, one that stretches back millennia. Indigenous cultures around the world have long held deep connections to the cosmos, viewing the stars not just as distant lights, but as guides, teachers, and storytellers. Their knowledge, passed down through generations, offers a unique perspective on the universe, one that is increasingly being recognized and integrated into modern space science. This blending of ancient wisdom and cutting-edge research is not just enriching our understanding of the cosmos, it's reshaping how we approach exploration itself. Take, for example, the ways indigenous peoples have used the stars for navigation. Polynesian voyagers, guided by the positions of stars, ocean currents, and even the behavior of birds, crossed vast stretches of the Pacific Ocean long before the invention of the compass or GPS. Their intricate star maps and oral traditions reveal a profound understanding of celestial patterns, one that modern astronomers are now studying to refine their own navigation techniques. By combining these ancient methods with satellite technology, researchers are uncovering new ways to explore both Earth and space, proving that traditional knowledge isn't just history, it's a living, evolving resource. Indigenous perspectives also offer valuable insights into environmental stewardship, a critical concern for both Earth and space exploration. Many indigenous cultures view the natural world as an interconnected system, where every element from the smallest plant to the largest star plays a vital role. This holistic approach aligns closely with modern ecological science, which emphasizes the delicate balance of Earth systems. For example, the Maori concept of Kaishiakitanga, or guardianship of the environment, has inspired sustainable practices in New Zealand and beyond. This philosophy resonates with space agencies, which are increasingly focused on minimizing their environmental impact, whether through reducing space debris or developing eco-friendly technologies. Collaborations between space agencies and indigenous communities are becoming more common, blending traditional knowledge with scientific research. One notable example is NAS, a partnership with the Navajo Nation to study the potential for life on Mars. The Navajo people, whose ancestral lands have geological similarities to the Martian landscape, have shared their deep understanding of desert ecosystems to help scientists identify promising sites for exploration. These partnerships are not just about data collection, they're about mutual respect and learning, demonstrating how diverse perspectives can drive innovation. Case studies further illustrate the value of this cultural exchange. In Australia, the Aboriginal and Torres Strait Islander peoples have long used their intricate knowledge of the night sky to track seasons, predict weather, and navigate the land. This knowledge, known as indigenous astronomy, is now being incorporated into educational programs and scientific research. For instance, the Wardaman people's understanding of the Milky Way has helped astronomers map the structure of our galaxy, offering new insights into its formation and evolution. These collaborations highlight how indigenous wisdom can complement and enhance modern science, creating a richer, more nuanced understanding of the universe. The integration of indigenous knowledge into space exploration also raises important questions about ethics and representation. For centuries, traditional knowledge has been marginalized or dismissed by Western science, but this is slowly changing. Space agencies and researchers are beginning to recognize the importance of including indigenous voices in discussions about exploration, conservation, and sustainability. This shift isn't just about fairness, it's about recognizing that diverse perspectives lead to better solutions. By valuing indigenous contributions, we're not only honoring their heritage, but also enriching our collective understanding of the cosmos. This cultural exchange goes beyond science. It's about fostering a deeper connection to the universe. Indigenous stories and traditions often emphasize the interconnectedness of all things, a perspective that resonates with the cosmic view of Earth as a fragile, interconnected system. This shared understanding can inspire more sustainable and inclusive approaches to space exploration, reminding us that the stars belong to everyone. As we continue to explore the cosmos, the wisdom of indigenous cultures offers a powerful reminder. The journey to the stars is not just about reaching new frontiers, but about understanding our place within the vast web of existence. The blending of indigenous knowledge with modern science is a testament to the power of collaboration. It shows that the pursuit of knowledge isn't a one-way street. It's a dialogue, a meeting of minds that enriches both sides. As we look to the future, this integration will undoubtedly play a key role in shaping how we explore the cosmos, offering new perspectives and solutions to the challenges we face. And in this journey, we're reminded that the stars are not just a destination, they're a shared heritage, a source of inspiration that unites us all. This brings us to the next chapter, how the lessons we learn from indigenous knowledge and cultural exchange can guide us in building a more inclusive and sustainable future, both in space and here on Earth. The influence of space exploration extends far beyond the cosmos. It reaches into the very fabric of how we govern and make decisions here on Earth. From shaping environmental regulations to forging international alliances, the data and insights gained from space science have become indispensable tools for policymakers. Space agencies, once seen as purely scientific entities, are now key players in the global effort to address pressing challenges, offering a bird's-eye view that informs evidence-based decision-making. One of the most significant ways space exploration impacts public policy is through its role in combating climate change. Satellites orbiting Earth provide real-time data on everything from greenhouse gas emissions to deforestation rates, offering policymakers the information they need to craft effective climate strategies. For instance, the European Space Agency's Copernicus program monitors global carbon dioxide levels, helping nations track their progress toward emissions reduction targets set by agreements like the Paris Accord. This data isn't just numbers on a screen, it's a call to action, a way to hold countries accountable and drive meaningful change. Disaster preparedness is another area where space exploration has revolutionized public policy. When hurricanes, wildfires, or earthquakes strike, every second counts. Satellites provide critical early warnings and detailed maps of affected areas, enabling governments to coordinate rescue efforts and allocate resources more effectively. Take Japan's response to the Fukushima disaster in 2011. Satellite imagery helped assess the extent of the damage, guiding relief operations and informing long-term recovery plans. These tools don't just save lives, they help communities rebuild and prepare for future crises. The intersection of space exploration and governance isn't limited to environmental or disaster-related policies. It also plays a crucial role in fostering international cooperation. Space agencies often collaborate across borders, sharing data and resources to tackle global challenges. The International Space Station, for example, is a shining example of what's possible when nations work together. This spirit of collaboration extends to Earth as well, with countries pooling their expertise to address issues like climate change, resource management, and even pandemic response. By transcending political boundaries, space exploration reminds us that some challenges are too big for any one nation to solve alone. Case studies further illustrate the profound impact of space science on public policy. Consider the Montreal Protocol, a landmark international agreement to phase out ozone-depleting chemicals. Satellite data played a key role in identifying the ozone hole over Antarctica, providing the evidence needed to galvanize global action. Today, thanks to this agreement, the ozone layer is slowly healing, a testament to the power of science-driven policy. Similarly, NASA's Earth Observing System has been instrumental in shaping U.S. climate policy, offering insights that inform everything from renewable energy initiatives to conservation efforts. Policymakers themselves recognize the value of space exploration in shaping effective governance. Former U.S. Vice President Al Gore, a vocal advocate for climate action, has often emphasized the importance of satellite data in understanding and addressing environmental challenges. Space gives us the tools to see the big picture, he once said, and that's essential for making smart, forward-thinking decisions. This sentiment is echoed by leaders around the world who see space science as a critical tool for navigating the complexities of the 21st century. The ripple effects of space exploration on public policy are undeniable. By providing a global perspective, space science helps us see the interconnectedness of our world, fostering a sense of shared responsibility that transcends borders. It's a reminder that the challenges we face, whether environmental, social, or geopolitical, are not isolated issues, but part of a larger, interconnected system. And in this system, collaboration isn't just an option, it's a necessity. As we continue to explore the cosmos, the lessons we learn will undoubtedly shape the policies of tomorrow. From climate agreements to disaster response plans, the data and insights gained from space science are helping us build a more resilient, sustainable future. And in this journey, we're reminded that the stars aren't just a destination, they're a guide, offering clarity and perspective as we navigate the challenges of life on Earth. This forward momentum sets the stage for the next chapter of our exploration, how the tools and technologies of space exploration are not only advancing science, but also shaping the future of global cooperation. As humanity reaches for the stars, we're not just discovering new worlds, we're unlocking new ways to power our own. Space exploration has always been a catalyst for innovation, and nowhere is this more evident than in the realm of energy. The extreme demands of space travel have driven the development of cutting-edge energy technologies, many of which are now transforming how we generate, store, and use energy here on Earth. From solar panels that power spacecraft to nuclear reactors that could fuel missions to Mars, the energy solutions born from space exploration are reshaping our energy future in ways that are both sustainable and revolutionary. Let's start with solar power, one of the most iconic energy innovations inspired by space. Solar panels were initially developed to power satellites and spacecraft, where traditional fuel sources were impractical. In the vacuum of space, solar energy is abundant and reliable, making it the perfect solution for long-duration missions. Over time, the technology has evolved, becoming more efficient and cost-effective. Today, solar panels are a cornerstone of the global push toward renewable energy, powering everything from homes and businesses to entire cities. The same lightweight, durable solar cells that keep the International Space Station running are now being adapted for use in solar farms and even portable chargers, bringing clean energy to communities around the world. But solar power is just the beginning. Space exploration has also driven advancements in nuclear energy, a technology with immense potential for both space and Earth. NASA Kilopower project, for example, is developing small, portable nuclear reactors capable of providing reliable energy for long-duration missions to the Moon and Mars. These reactors use uranium-235 to generate heat, which is then converted into electricity, offering a compact and efficient energy source that could sustain human habitats on other planets. On Earth, this technology could revolutionize energy access in remote or disaster-stricken areas, providing a reliable power source where traditional infrastructure is lacking. Energy storage is another area where space exploration is making a significant impact. Batteries are critical for storing the energy collected by solar panels on spacecraft, but the harsh conditions of space demand batteries that are lightweight, durable, and capable of withstanding extreme temperatures. Innovations in battery technology, driven by these demands, are now being applied to Earth-based solutions. For instance, lithium-ion batteries, originally developed for space missions, are now powering everything from electric vehicles to grid-scale energy storage systems. These advancements are helping to address one of the biggest challenges of renewable energy: storing power for use when the sun isn't shining or the wind isn't blowing. One standout example of space-inspired energy innovation is the development of concentrated solar power, or CSP. This technology uses mirrors or lenses to focus sunlight onto a small area, generating intense heat that can be converted into electricity. CSP systems are being tested for use in space habitats, where they could provide a steady and efficient energy source. On Earth, CSP is already being used in large-scale solar farms, such as the Ivanpah Solar Electric Generating System in California, which generates enough electricity to power over 100,000 homes. By harnessing the power of the sun, CSP offers a sustainable alternative to fossil fuels, reducing greenhouse gas emissions and helping to combat climate change. The transformative potential of these technologies is already being realized. In Morocco, the Noor Ouarzazate Solar Complex, one of the largest solar farms in the world, uses CSP technology to provide clean energy to millions of people. Similarly, in Australia, advanced battery systems inspired by space technology are being used to stabilize the electrical grid and integrate more renewable energy sources. These projects demonstrate how the innovations born from space exploration are not just theoretical, they're making a tangible difference in our energy landscape. As we continue to explore the cosmos, the lessons we learn about energy will play a crucial role in shaping our future. Space exploration challenges us to think creatively, to push the boundaries of what's possible, and to develop solutions that are both efficient and sustainable. These innovations aren't just about powering rockets or space stations. They're about creating a more sustainable and resilient energy future for everyone. From solar farms that stretch across deserts to portable nuclear reactors that bring power to remote communities, the energy technologies inspired by space exploration are lighting the way toward a brighter, cleaner future. This journey into the stars is not just about reaching new frontiers, it's about reimagining how we power our world. And as we harness the energy solutions born from space, we're reminded that the cosmos isn't just a place of wonder, it's a source of inspiration, innovation, and hope for a sustainable tomorrow. Space exploration has often been seen as a pursuit of the privileged, a luxury reserved for nations with vast resources. But what if it could be the opposite, a tool for leveling the playing field and addressing some of the world's most persistent inequalities, from improving access to education and healthcare to bridging the digital divide? Space technology is proving to be a powerful force for social justice, empowering marginalized communities and creating opportunities where they were once scarce. One of the most transformative applications of space technology is in education. In remote or underserved regions, where schools are few and far between, satellites are bringing the classroom to the students. Initiatives like the United Nations Sustainable Development Goals have leveraged satellite-based internet to connect schools in rural Africa to online learning platforms, offering children access to lessons and resources that were once out of reach. For example, in Kenya, the I Mlango project uses satellite broadband to deliver digital education to over 150,000 students, many of whom live in areas without reliable electricity or infrastructure. These programs aren't just about access to information, they're about opening doors to a brighter future, giving children the tools to dream beyond their circumstances. Healthcare is another area where space technology is making a profound difference. In many developing countries, access to medical facilities is limited, and the quality of care can vary widely. Satellites are helping to bridge this gap by enabling telemedicine, where doctors can consult with patients remotely using high-speed internet connections. In India, the eHealth Africa initiative uses satellite technology to provide healthcare services to rural communities, offering everything from diagnostic imaging to specialist consultations. This approach not only improves health outcomes, but also reduces the burden on overstretched healthcare systems, proving that space exploration can be a lifeline for those who need it most. Clean water, a basic human right that remains out of reach for millions, is another challenge being addressed through space innovation. Satellites equipped with advanced sensors can map groundwater reserves and monitor water quality, helping communities identify safe sources and plan sustainable water management strategies. In Ethiopia, satellite data has been used to locate underground aquifers, providing clean water to villages that previously relied on contaminated sources. Projects like these show how space technology can tackle some of the most fundamental inequalities, giving people the resources they need to thrive. Perhaps one of the most visible ways space exploration is reducing inequality is through satellite internet. The digital divide, the gap between those with and without access to the internet, is one of the greatest barriers to equality in the modern world. Companies like SpaceX's Starlink and OneWeb are working to close this gap by deploying constellations of satellites that provide high-speed internet to even the most remote corners of the globe. In Alaska, for instance, Starlink has brought reliable internet to indigenous communities, enabling everything from online education to telehealth services. By connecting these communities to the global digital economy, satellite internet is helping to level the playing field, offering opportunities that were once unimaginable. Case studies further highlight the transformative potential of space technology. Take the Satellite for Biodiversity and Environmental Monitoring project in the Amazon rainforest. This initiative uses satellite imagery to monitor deforestation and protect indigenous lands, empowering local communities to advocate for their rights and preserve their way of life. Similarly, in Nepal, satellite data has been used to map earthquake-prone areas, helping to build safer homes and schools in vulnerable regions. These projects demonstrate how space exploration can empower marginalized communities, giving them the tools to take control of their futures. At its core, space exploration is about expanding possibilities not just for a select few, but for everyone. By harnessing the power of satellites and other space technologies, we can address some of the most pressing inequalities of our time, from access to education and healthcare to clean water and digital connectivity. These efforts are more than just technical solutions. They're a testament to the potential of space exploration to promote social justice and create a more equitable world. This shift toward inclusivity in space exploration is not just a moral imperative, it's a practical one. When we invest in technologies that uplift the most vulnerable, we're not just improving individual lives, we're strengthening the fabric of our global community. And as we continue to explore the cosmos, we're reminded that the stars aren't just a destination, they're a source of inspiration, innovation, and hope for a more just and equal future. This forward momentum sets the stage for the next chapter of our exploration, how the tools and technologies of space exploration are not only advancing science, but also shaping the future of global cooperation and shared prosperity. Space exploration isn't just about discovering what's out there. It's also about uncovering the story of how it all began. Every star, every galaxy, every speck of light we see in the night sky is a clue to the origins of the universe itself. From the explosive birth of the cosmos in the Big Bang to the intricate dance of galaxies forming over billions of years, space exploration is helping us piece together the grand narrative of existence. And in this quest, tools like the James Webb Space Telescope are rewriting what we thought we knew about the universe's beginnings. Launched in 2021, the James Webb Space Telescope, or JWST, is a marvel of engineering and ambition. Positioned nearly 1 million miles from Earth, it peers deeper into space and further back in time than any telescope before it. Its infrared vision allows it to cut through cosmic dust, revealing the faint glow of the universe's first galaxies. These ancient structures, formed just a few 100 million years after the Big Bang, are like cosmic fossils, offering a glimpse into the universe's infancy. Already, JWST has discovered galaxies so massive and mature that they've challenged our understanding of how quickly the universe evolved. It's as if we've opened a time capsule and found something that defies all expectations. But the story of cosmic origins doesn't end with galaxies. There's still the mystery of dark matter and dark energy, two invisible forces that make up more than 95% of the universe. Dark matter, though we can't see it, reveals its presence through its gravitational pull, holding galaxies together like cosmic glue. Dark energy, on the other hand, is the mysterious force driving the universe's accelerated expansion. Together, these two phenomena shape the fate of the cosmos, yet they remain some of the most profound puzzles in science. Missions like the European Space Agency's Euclid telescope, set to launch in the coming years, aim to map the distribution of dark matter and measure the effects of dark energy, bringing us closer to understanding these enigmatic forces. Astronomers often describe the search for cosmic origins as a detective story, where every observation is a clue and every discovery raises new questions. Take the cosmic microwave background. For example, this faint afterglow of the Big Bang is like a snapshot of the universe when it was just 380,000 years old. By studying this ancient light, scientists have pieced together a timeline of the universe's evolution, from its fiery beginnings to the vast, intricate web of galaxies we see today. Yet for every answer, there's a new mystery. Why is the universe expanding faster than we thought? What caused the initial conditions of the Big Bang? These questions remind us that the cosmos is a place of endless wonder, where every discovery leads to new frontiers of understanding. Visualizing the scale of the universe can be both humbling and awe-inspiring. Imagine standing on a beach holding a single grain of sand. That grain, in the grand scheme of things, is like our Milky Way galaxy, just one of billions in the observable universe. Now, imagine the entire beach stretching out before you, each grain representing another galaxy, each with its own stars, planets, and possibilities. This is the cosmic perspective, a reminder of how vast and interconnected the universe truly is. And yet, even in this immense expanse, Earth remains a singular haven, a place where life has taken root against all odds. Understanding the origins of the universe isn't just about satisfying curiosity. It's about gaining a deeper appreciation for our place within it. When we look at the night sky, we're not just seeing distant stars. We're seeing the echoes of cosmic history, the remnants of a story that began nearly 14 billion years ago. This knowledge transforms how we see Earth, not as an isolated world, but as part of a grand, unfolding narrative. It's a perspective that inspires both humility and wonder, reminding us that we are not just observers of the cosmos. We are its children, born from the stars themselves. As we continue to explore the universe, we're not just uncovering its secrets, we're uncovering our own. Every discovery, from the faintest galaxies to the most elusive particles, adds a new chapter to the story of who we are and where we came from. And in this journey, we're reminded that the cosmos isn't just a place to explore, it's a mirror, reflecting the boundless curiosity and resilience of the human spirit. As we gaze into the stars, we often forget that space exploration also allows us to look back not just in time, but into the very history of our own planet. The tools we've developed to study distant galaxies and alien worlds are also helping us uncover the secrets of Earth's ancient past. From the rise and fall of ancient landscapes to the cataclysmic events that shaped life as we know it, space science is rewriting the story of our planet's history, offering us a deeper understanding of where we've come from and where we might be headed. One of the most powerful tools in this quest is satellite imagery. Orbiting high above Earth, satellites capture more than just stunning photos. They reveal the hidden fingerprints of our planet's geological and biological evolution. For example, satellite data has been used to map ancient river systems buried beneath the sands of the Sahara Desert, offering clues about a time when this vast expanse was a lush, green landscape teeming with life. These discoveries aren't just fascinating, they are windows into a world that existed millions of years ago, showing us how Earth's climate and ecosystems have transformed over time. Space exploration also plays a critical role in understanding mass extinctions, those dramatic events that have reshaped life on Earth. One of the most famous examples is the asteroid impact that wiped out the dinosaurs 66 million years ago. By studying impact craters like Chicxulub in Mexico, scientists have been able to piece together the catastrophic chain of events that followed the collision. Satellites provide detailed maps of these craters, helping researchers understand the scale of the impact and its global consequences. This knowledge isn't just about the past, it's a reminder of how fragile life can be and how vulnerable Earth is to cosmic threats. But it's not just asteroids that have shaped Earth's history. Climate shifts, driven by natural forces and, more recently, human activity, have also left their mark. Satellites like NASA Terra and Aqua track changes in Earth's surface and atmosphere, offering a long-term view of how our planet has responded to these shifts. For instance, data from these missions has revealed the dramatic retreat of glaciers over the past century, providing stark evidence of the impact of global warming. By studying these patterns, scientists can better predict how Earth's climate might change in the future, helping us prepare for the challenges ahead. One remarkable example of space science reshaping our understanding of Earth's history comes from the study of the Permian-Triassic extinction, often called the Great Dying. This event, which occurred around 252 million years ago, wiped out nearly 96% of marine species and 70% of terrestrial life. By analyzing sediment layers and fossil records, data often enhanced by satellite imagery, scientists have uncovered evidence that massive volcanic eruptions in what is now Siberia triggered catastrophic climate change. This discovery not only sheds light on Earth's distant past, but also underscores the interconnectedness of geological and biological systems. The insights gained from space exploration don't just deepen our understanding of Earth's history, they also inform our future. By studying the causes and consequences of past climate shifts and mass extinctions, we can better anticipate the challenges we face today. For example, the same satellite data used to track ancient landscapes is now being used to monitor deforestation, melting ice caps, and rising sea levels, providing a clear picture of how human activity is reshaping the planet. This knowledge empowers us to make informed decisions about conservation, sustainability, and climate action. What makes this intersection of space science and Earth's history so powerful is its ability to connect the dots between the past, present, and future. Every discovery, whether it's an ancient riverbed or a long-lost crater, adds a piece to the puzzle of our planet's story. And as we piece together this narrative, we're reminded of our responsibility to protect the fragile world we call home. The same tools that help us explore the cosmos also allow us to see Earth with fresh eyes, appreciating its beauty, its complexity, and its vulnerability. As we continue to explore the universe, the lessons we learn about Earth's past will guide us in shaping a more sustainable and resilient future. This journey isn't just about reaching new frontiers, it's about understanding the one we already inhabit. And in that understanding, we find not just knowledge, but hope, a hope that, by learning from the past, we can build a better tomorrow. This forward momentum sets the stage for the next chapter of our exploration, how the tools and technologies of space exploration are not only uncovering Earth's history, but also shaping our strategies for preserving its future. Space exploration isn't just a scientific endeavor, it's a deeply human one, rooted in a philosophy as old as civilization itself. At its core, exploration is driven by curiosity, the relentless desire to understand the unknown, and the courage to venture beyond the familiar. Philosophers throughout history have wrestled with this impulse, from Aristotle's musings on the nature of knowledge to Carl Sagan's poetic reflections on the cosmos. Exploration, they argue, isn't just about discovering new places. It's about discovering ourselves, about pushing the boundaries of what we know, and in the process, redefining what it means to be human. Consider the metaphor of a ship setting sail into uncharted waters. For centuries, explorers like Magellan and Columbus braved the unknown, driven by a mix of curiosity, ambition, and the hope of finding something greater. Space exploration is no different. When we send probes to distant planets or launch astronauts into orbit, we're following the same instinct that once propelled ships across vast oceans. The universe is our new frontier, and every mission is a testament to our unyielding desire to explore, to learn, and to grow. Philosophers have long recognized exploration as a fundamental aspect of the human condition. Immanuel Kant, for example, spoke of the sublime, the awe-inspiring feeling we experience when confronted with the vastness of the cosmos. This sense of wonder, he argued, isn't just an emotional response, it's a call to action, a reminder that our curiosity is what propels us forward. Similarly, modern thinkers like Neil deGrasse Tyson emphasize that exploration isn't just about the destination, it's about the journey. The act of exploration, he says, is what defines us as a species. It's how we evolve, how we adapt, and how we survive. Space exploration embodies this philosophy in its purest form. When we look at the night sky, we're not just seeing stars, we're seeing possibilities. Every mission, from the Apollo moon landings to the Mars rovers, is a step into the unknown, a chance to answer questions that have puzzled us for millennia. But it's also more than that. Exploration is a way of confronting our limitations, of testing our ingenuity and resilience. It's about proving that no challenge is too great, no frontier too distant for the human spirit to conquer. This philosophy of exploration doesn't just apply to space, it shapes how we approach challenges here on Earth. When faced with global crises like climate change or resource scarcity, the same spirit of curiosity and determination drives us to seek solutions. Just as astronauts rely on teamwork and innovation to survive in the harsh environment of space, we must work together to navigate the complexities of life on Earth. Exploration teaches us that the unknown isn't something to fear, it's something to embrace, a source of inspiration and opportunity. The journey of exploration is also a journey of self-discovery. When we push the boundaries of what's possible, we're not just learning about the universe, we're learning about ourselves. We're reminded of our capacity for creativity, for resilience, and for hope. And in that process, we find not just answers, but meaning, The stars, in this sense, are more than distant lights, they are mirrors, reflecting our deepest aspirations and our boundless potential. As we continue to explore the cosmos, we're not just uncovering the secrets of the universe, we're uncovering the essence of what it means to be human. And in that discovery, we find the true power of exploration, not just to take us to new worlds, but to help us see our own world and ourselves in a new light. This philosophy, this drive to explore, is what will guide us as we face the challenges of tomorrow, both in space and here on Earth. And in that journey, we'll find not just knowledge, but a deeper understanding of our place in the grand tapestry of existence. Space exploration does more than expand our knowledge of the cosmos. It reshapes how we see ourselves and the values we hold dear. From fostering international cooperation to inspiring a deeper commitment to environmental stewardship, the journey beyond Earth has profound implications for how we live and interact with one another. It's not just about reaching new frontiers. It's about discovering what it means to be human in a universe that demands collaboration, resilience, and innovation. One of the most striking lessons from space exploration is the power of teamwork. Missions like the International Space Station are testaments to what humanity can achieve when nations set aside differences and work toward a common goal. Astronauts from the United States, Russia, Europe, Japan, and other countries live and work together in an environment where survival depends on mutual trust and collaboration. As astronaut Peggy Whitson once said, "In space, you quickly realize that borders don't exist. We're all part of the same team, working toward the same objectives." This spirit of unity extends beyond the walls of the ISS, offering a model for how we can tackle global challenges like climate change, poverty, and conflict. Resilience is another value that space exploration instills. Living and working in the harsh environment of space requires adaptability and perseverance. Astronauts face physical and psychological challenges, from the effects of microgravity on the body to the isolation of being far from home. Yet, they find ways to thrive, developing innovative solutions to problems that arise. Chris Hadfield, who spent months aboard the ISS, often speaks about the importance of preparation and adaptability. "You can't predict every challenge," he says, "but you can train yourself to respond with creativity and calm." This mindset isn't just valuable in space, it's a lesson for anyone facing adversity, reminding us that challenges are opportunities to grow. Innovation, too, is a cornerstone of space exploration. The demands of space travel push engineers, scientists, and astronauts to think outside the box, creating technologies that often have far-reaching applications on Earth. Take, for example, the development of water recycling systems for the ISS. Originally designed to sustain astronauts on long-duration missions, these systems are now being used to provide clean water in remote and disaster-stricken areas. This kind of ingenuity demonstrates how space exploration drives progress, not just in science and technology, but in solving real-world problems. The personal transformations experienced by astronauts also offer profound insights into human values. Many who have seen Earth from space describe a shift in perspective known as the overview effect. From orbit, the planet appears as a fragile, interconnected system, devoid of the borders and divisions that often define life on the ground. Edgar Mitchell, one of the Apollo astronauts, famously described this experience as a gut-level understanding that we're all part of one global family. This sense of interconnectedness often leads astronauts to become advocates for environmental protection and global cooperation, using their experiences to inspire others to think beyond individual or national interests. Anecdotes from space missions further illustrate the impact of these values. During the Apollo 13 mission, when an oxygen tank exploded, threatening the lives of the crew, it was the combined efforts of NASA, a ground team, and the astronauts themselves that turned a potential disaster into a successful failure. Their ability to work together under extreme pressure not only saved lives, but also demonstrated the power of teamwork and ingenuity. Stories like these remind us that the lessons of space exploration are not just theoretical. They are lived experiences that shape how we approach challenges, both big and small. Perhaps most importantly, space exploration inspires a sense of global citizenship. When we look at Earth from space, we see a world without borders, a shared home that demands our care and stewardship. This perspective fosters a sense of responsibility not just for our own communities, but for the entire planet. It's a reminder that the challenges we face, whether environmental, social, or technological, are global in nature, and so too must be our solutions. As we continue to explore the cosmos, these values, cooperation, resilience, innovation, and global citizenship, will guide us not just in space, but here on Earth. They remind us that the journey to the stars is not just about reaching new destinations, it's about becoming better stewards of our planet and better neighbors to one another. In this way, space exploration isn't just a scientific endeavor, it's a call to action, urging us to build a future that reflects the best of what humanity can achieve. This brings us to the next chapter, how the tools and technologies developed for space exploration are not only advancing science, but also shaping the future of global cooperation and shared prosperity. Space exploration isn't just about rockets and distant planets, it's reshaping the very nature of work here on Earth. As we venture further into the cosmos, new industries are emerging, creating opportunities that were once the stuff of science fiction. From engineers designing spacecraft to biologists studying the effects of microgravity on human health, the jobs of tomorrow are being forged in the laboratories, launch pads, and boardrooms of today. This shift isn't just about creating new roles, it's about redefining what it means to work in a world where the boundaries between Earth and space are becoming increasingly blurred. One of the most exciting developments is the rise of space tourism. Companies like SpaceX, Blue Origin, and Virgin Galactic are turning the dream of traveling to space into a reality for private citizens. This burgeoning industry isn't just about thrill seekers, it's creating a ripple effect across the economy. From hospitality, professionals trained to cater to space tourists to engineers developing safer, more efficient spacecraft, the demand for specialized skills is growing. Experts predict that by 2040, space tourism could be a multi-billion-dollar industry, generating thousands of jobs and spurring innovation in areas like sustainable travel and advanced materials. But the impact of space exploration on the job market goes far beyond tourism. The skills required for space-related industries are reshaping education and training programs worldwide. Universities are introducing courses in astrobiology, space law, and planetary geology, preparing students for careers that didn't exist a decade ago. Technical skills, such as coding, robotics, and artificial intelligence, are becoming increasingly valuable as space agencies and private companies rely on cutting-edge technology to solve complex problems. At the same time, soft skills like adaptability, teamwork, and creative problem-solving are in high demand, reflecting the collaborative and unpredictable nature of space exploration. Take the story of Dr. Mae Jemison, the first African-American woman in space. After her historic mission, she founded the Jemison Group, a company that develops technology to improve life on Earth and in space. Her work highlights how space exploration isn't just about reaching new frontiers. It's about applying the lessons learned to solve real-world challenges. Companies like hers are creating jobs that blend science, engineering, and entrepreneurship, offering opportunities for innovation and growth in fields as diverse as healthcare, agriculture, and renewable energy. Economists and industry leaders are already seeing the potential for space exploration to drive economic growth. Dr. Scott Pace, former Executive Secretary of the U.S. National Space Council, notes that space is not just a place to explore, it's a place to do business. He points to the growing demand for satellite services, from telecommunications to weather forecasting, as an example of how space-based technologies are transforming industries. These advancements are creating jobs not just for scientists and engineers, but also for data analysts, project managers, and even marketers who can communicate the value of space-based solutions to the public. The skills and technologies developed for space exploration are also preparing us for the challenges of the future. As we face issues like climate change, resource scarcity, and technological disruption, the lessons learned in space are proving invaluable. For instance, the precision and efficiency required to sustain life in the harsh environment of space are inspiring innovations in sustainable agriculture and renewable energy. The ability to collaborate across borders and disciplines, essential for space missions, is fostering a new culture of global cooperation that can address shared challenges on Earth. This evolution in the workforce isn't just about adapting to change, it's about embracing possibility. Space exploration challenges us to think bigger, to imagine new ways of living and working that extend beyond the boundaries of our planet. It's a reminder that the future of work isn't something that happens to us. It's something we create through curiosity, innovation, and a commitment to pushing the limits of what's possible. And as we continue to explore the stars, we're not just shaping the jobs of tomorrow, we're shaping the future of humanity itself. This forward momentum sets the stage for the next chapter of our exploration. How the tools and technologies of space exploration are not only advancing science, but also shaping the future of global cooperation and shared prosperity. Space exploration has always been a beacon for innovation, pushing the boundaries of what we thought was possible and sparking advancements that ripple far beyond the stars. The challenges of exploring the cosmos, extreme temperatures, limited resources, and the need for precision drive engineers and scientists to think creatively, often leading to breakthroughs that transform life on Earth. From robotics to materials science, the technologies born from space exploration have reshaped industries, improved everyday life, and even saved lives. One of the most iconic examples of space-inspired innovation is memory foam. Originally developed by NASA in the 1960s to improve the safety and comfort of aircraft seats, this material has since become a household staple, found in everything from mattresses to medical cushions. Its ability to absorb impact and conform to the body has revolutionized comfort and support, proving that the solutions designed for space can have profound applications right here on Earth. Similarly, scratch-resistant lenses, first created to protect astronaut helmet visors from the harsh conditions of space, are now a standard feature in eyeglasses and camera lenses, offering durability and clarity to millions. Robotics is another field that has been profoundly shaped by space exploration. The rovers exploring Mars, like NASA Perseverance, are marvels of engineering, equipped with advanced sensors and autonomous navigation systems. These technologies aren't just for distant planets, they're being adapted for use in industries like healthcare and disaster response. Imagine a robot performing delicate surgeries with the precision of a Mars rover or navigating disaster zones to locate survivors. These aren't just futuristic ideas, they're real-world applications of space-driven innovation. Materials science, too, has benefited immensely from the demands of space travel. The need for lightweight, durable materials that can withstand extreme conditions has led to the development of advanced composites and alloys. These materials are now used in everything from aircraft and automobiles to sports equipment and even smartphones. For instance, the heat-resistant ceramics used in spacecraft re-entry shields have inspired safer, more efficient cooking tools like non-stick pans. It's a testament to how solving problems in space can lead to unexpected solutions on Earth. The creative process behind these innovations is as fascinating as the technologies themselves. Engineers and scientists often describe space exploration as a crucible for innovation, where constraints force them to think outside the box. Dr. Ellen Stoffen, former NASA chief scientist, explains, "When you're designing for space, you can't afford to carry extra weight or take unnecessary risks." That pushes us to be more efficient, more precise, and more imaginative. This mindset doesn't just apply to space missions. It influences how we approach challenges in every field, from healthcare to renewable energy. The impact of these spin-off technologies is felt across industries. In medicine, space-inspired advancements have led to more accurate diagnostic tools and better prosthetics. In agriculture, satellite data and precision farming techniques are helping farmers optimize crop yields and reduce waste. Even in everyday life, the ripple effects are undeniable. Whether it's the water filtration systems developed for the International Space Station, now providing clean drinking water in remote areas, or the solar panels powering homes and businesses, inspired by those used on spacecraft. What makes this intersection of space exploration and innovation so powerful is its ability to inspire. Every breakthrough, from memory foam to autonomous robots, is a reminder of what humanity can achieve when we dare to dream big. It's not just about solving the challenges of space, it's about using those solutions to improve life on Earth. And in this process, we're reminded that the journey to the stars is as much about discovering new possibilities as it is about reaching new destinations. As we continue to explore the cosmos, the technologies we develop will keep transforming our world in ways we can't yet imagine. Space exploration isn't just a source of inspiration, it's a catalyst for progress, driving us to innovate, adapt, and thrive. And in this journey, we're not just reaching for the stars, we're shaping a future that reflects the best of what humanity can achieve. As we set our sights on colonizing other worlds, we're faced with more than just technical challenges, we're confronted with profound ethical questions. What does it mean to responsibly explore and settle new frontiers? How do we balance our ambitions with the need to preserve extraterrestrial environments? These aren't just hypothetical debates, they're urgent considerations that will shape the future of space exploration and humanity itself. One of the most pressing ethical dilemmas revolves around resource allocation. Space is often portrayed as a limitless frontier, but the reality is more complex. Take the Moon, for example. Its surface is rich in helium-3, a rare isotope that could revolutionize energy production on Earth. But who has the right to extract and use these resources? If one nation or corporation claims ownership, Does that exclude others? These questions aren't just about fairness. They're about ensuring that space exploration benefits all of humanity, not just a privileged few. The Outer Space Treaty of 1967 provides some guidance, declaring that space is the province of all mankind and prohibiting nations from claiming sovereignty over celestial bodies. But as private companies and international coalitions push forward with plans for lunar bases and asteroid mining, the treaty's limitations are becoming apparent. It doesn't explicitly address commercial activities or resource extraction, leaving gray areas that ethicists and policymakers are now grappling with. Some argue that we need new frameworks to ensure that space exploration remains a shared endeavor, one that prioritizes sustainability and equity. Beyond resource allocation, there's the question of how we treat extraterrestrial environments. Mars, with its barren landscapes and thin atmosphere, might seem like a blank slate for human settlement, but what if microbial life exists beneath its surface? How do we reconcile our desire to explore and colonize with the responsibility to protect potential ecosystems? Ethicists like Dr. Lucian Wakovich emphasize the importance of humility in these efforts. We have a chance to do things differently in space, she says, to learn from the mistakes we've made on Earth and create a future that's more just and sustainable. The rights of future space settlers add another layer of complexity. If humans establish permanent settlements on the Moon or Mars, what legal and ethical frameworks will govern their lives? Will they be subject to the laws of their home countries, or will they develop their own systems of governance? These questions aren't just about logistics, they are about justice and autonomy. How do we ensure that space settlers have a say in their own futures, while also upholding principles of fairness and equality? International agreements will play a crucial role in addressing these challenges. Organizations like the United Nations Office for Outer Space Affairs are already working to establish guidelines for responsible space exploration. These efforts aim to create a framework that balances the interests of nations, corporations, and individuals, ensuring that space remains a shared resource for the benefit of all. But as we venture further into the cosmos, these agreements will need to evolve, adapting to new challenges and opportunities. Thought-provoking scenarios can help us grapple with these ethical dilemmas. Imagine a future where a multinational corporation establishes a colony on Mars, extracting resources for profit while excluding others from access. How would we respond? Or consider a scenario where scientists discover microbial life on Europa, one of Jupiter's moons. Would we prioritize exploration or preservation? These questions force us to confront the values we want to carry into space, challenging us to think beyond short-term gains and consider the long-term implications of our actions. Space colonization isn't just about finding new places to live, it's about redefining what it means to be human. It forces us to confront our values, our responsibilities, and our place in the universe. As we look to the stars, we're reminded that the journey into space is as much about discovering ourselves as it is about discovering new worlds. And in this journey, we have the opportunity to build a future that reflects the best of what humanity can achieve, one that balances exploration with responsibility, ambition with humility, and innovation with ethics. This forward momentum sets the stage for the next chapter of our exploration, how the lessons we learn from space colonization can inspire us to create a more equitable and sustainable future, both in the cosmos and here on Earth. The cosmic perspective isn't just a way of seeing the universe, it's a way of imagining our future. When we look at Earth from space, we don't see borders or nations, We see a single, fragile home floating in the vastness of the cosmos. This view has the power to reshape how we think about humanity's place in the universe, inspiring us to dream bigger and work together in ways we never thought possible. It's a perspective that doesn't just challenge us to explore the stars, it challenges us to become better stewards of our planet and better neighbors to one another. One of the most profound impacts of the cosmic perspective is its ability to unite us. In a world often divided by politics, culture, and ideology, space exploration offers a shared goal that transcends these differences. The International Space Station is a shining example of what's possible when nations collaborate, with astronauts from around the globe living and working together in harmony. As astronaut Scott Kelly once said, "From space, you don't see the things that divide us. You see how interconnected we are, how fragile our planet is, and how much we need to protect it." This sense of unity isn't just poetic, it's practical. If we can work together to explore the cosmos, why not apply that same spirit to solving challenges like climate change, poverty, and inequality? The cosmic perspective also pushes us to think long-term, beyond the immediate concerns of daily life. It reminds us that humanity's story is still being written, and that the choices we make today will shape the future for generations to come. Visionaries like Elon Musk and organizations like NASA are already laying the groundwork for a multi-planetary future, with plans to establish colonies on the Moon and Mars. These aren't just scientific endeavors, they're acts of optimism, a belief that humanity can not only survive but thrive, even in the harshest environments. As Carl Sagan eloquently put it, "The sky calls to us. If we do not destroy ourselves, we will one day venture to the stars." But the future of humanity isn't just about leaving Earth, it's about improving life here as well. The technologies and insights gained from space exploration are already transforming how we live, from renewable energy systems inspired by solar panels to water filtration techniques developed for space missions. These innovations show that the journey to the stars isn't just about reaching new frontiers, it's about creating a better world for everyone. It's a reminder that the challenges we face, whether on Earth or in space, are opportunities to innovate, collaborate, and grow. Imagine a future where humanity thrives not just on Earth, but across the solar system. Picture cities on Mars powered by renewable energy, lunar bases conducting groundbreaking research, and spacecraft venturing to distant stars in search of new discoveries. This vision isn't just science fiction, it's a possibility within our reach if we have the courage to pursue it. And as we take these bold steps, we're reminded that the cosmos isn't just a destination, it's a source of inspiration, a reminder of what we can achieve when we work together and dream big. As we reflect on the cosmic perspective, one thing becomes clear: the future of humanity is not a fixed path, but a canvas waiting to be painted. Space exploration gives us the tools to imagine a brighter, more unified future, one where we rise above our differences and embrace our shared humanity. It's a vision that challenges us to think beyond ourselves, to see the bigger picture, and to act with purpose and hope. The stars may be distant, but the future they inspire is closer than we think, if only we dare to reach for it. This brings us to the heart of our journey, the lessons we've learned about exploration, unity, and the boundless potential of the human spirit. As we look to the stars, we're reminded that the cosmos isn't just a place to visit. It's a mirror reflecting the best of who we are and who we can become. As we bring this journey to a close, it's worth pausing to reflect on how space exploration has fundamentally reshaped our understanding of Earth. From the awe-inspiring overview effect that transforms how astronauts, and, by extension, all of us see our planet, to the countless technological innovations that have improved life on the ground, the impact of venturing beyond our atmosphere is profound and far-reaching. What began as a quest to explore the stars has become a mirror, revealing not just the mysteries of the cosmos but the beauty, fragility, and interconnectedness of our own world. The overview effect, that profound shift in perspective experienced by astronauts when they see Earth from space, isn't just a personal revelation, it's a universal call to action. It reminds us that borders and divisions are human constructs, and that the challenges we face, climate change, resource scarcity, inequality, are global in nature. This cosmic perspective fosters a sense of unity, urging us to think beyond individual or national interests and work together for the greater good. It's a reminder that Earth isn't just our home, it's our shared responsibility. But the benefits of space exploration go beyond philosophy. The technologies born from the demands of space travel have revolutionized life on Earth. Solar panels, water filtration systems, and advanced medical tools are just a few examples of how solving problems in space has led to breakthroughs here at home. These innovations aren't just about convenience, they're about survival, sustainability, and progress. They show us that the journey to the stars isn't just about reaching new frontiers, it's about creating a better future for everyone. The cosmic perspective also challenges us to think long-term, to consider the legacy we're leaving for future generations. It's a call to action, urging us to protect our planet, embrace sustainable practices, and invest in solutions that benefit all of humanity. Whether it's through supporting renewable energy, advocating for global cooperation, or simply taking a moment to marvel at the night sky, each of us has a role to play in shaping a brighter future. As we look to the stars, we're reminded that the universe is vast, mysterious, and full of possibilities, but it's also a reminder of how precious and unique Earth is. There's no backup planet, no second chance. The cosmic perspective isn't just about exploring the unknown, it's about cherishing what we have and working together to protect it. So, what can you do with this perspective? Start by looking up. Take a moment to appreciate the night sky, to marvel at the stars, and to reflect on your place in the universe. Share your thoughts, your questions, and your dreams with others. Engage with the wonders of the cosmos, whether through citizen science projects, educational programs, or simply by staying curious. And most importantly, let this perspective inspire you to take action, whether it's in your community, your career, or your daily life. The journey of space exploration is far from over. As we continue to push the boundaries of what's possible, let's carry this cosmic perspective with us, not just as a way of seeing the universe, but as a way of living. Together, we can build a future that reflects the best of humanity, one that's innovative, collaborative, and deeply connected to the world around us. Thank you for joining us on this journey through the cosmos. If this video has sparked your curiosity, share it with others and let's keep exploring together. The stars are calling. What will